it's a way to push that public policy. Also, from a federal perspective, we're starting to engage in federal dialogue across a host of members and other folks in D.C. Again, if anyone is involved in that, whether you have an arm of the company that can engage in certain ways with D.C., otherwise, that's going to be something that's federal action probably is not going to be the trick in terms of right education, but it doesn't mean that there couldn't be some sort of federal action.
All these kinds of places make it seem like it's been ages, and tomorrow's sun we're building a scrape sky. I love this country dearly, I can feel the ladder clearly, but I never thought I'd be alone to try. Once I was outside Penn Station, selling red and white carnations. We were still alone, my wife and I. Before we married, saved my money, brought my dear wife over. Now I work to bring my family stateside. But off the boat they stayed a while and scattered across the coast. Once a year I'll see them for a week or so at most. I take a walk, 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 take a walk. Practice isn't perfect, but the market cuts a loss. I remind myself that times could be much worse. My wife won't ask me questions, there's not so much to ask, and she'll never float around an empty purse. Once my mother came just to stay a couple nights, and decided that she would stay the rest of her life. I watch my little children, there's a book in the kitchen, and I sit and pray they never feel my strife. But then my partner called to say the pension funds were gone. We made some bad investments, now the accounts are overdrawn. I took a walk, take 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 a walk.
But we know that people can't do that with very
Honey, it's your son, I think I brought just too much. We had taxes, we had bills, we had a lifestyle of fun. And tonight I swear I'll come home and we'll make love like we're young. Tomorrow you'll cook dinner for the neighbors and the kids. We can rip apart those socialists and all their damn taxes. But see, I am no criminal, I'm down on both bad knees. I'm just too much a coward to admit when I'm in need. I took a walk, take 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 a walk,
any kind of party. People who are being crushed by student loans, you'll be able to find that, right? Because we really want to populate that section. But all of that and more, that's what we want to have in that new and notable section, so that it's just a wellspring of financial literacy-related materials. We talked about the program initiative directory, which will live on the portal. Talked about the work streams. We'll have an app. You'll see.
Body to body, just let me open your door. Bottle rockets are blowing, hands are exploring. Position myself how you like. Whiskey makes me controlling. I give for nothing, let go and live for a night. Tell me nothing, show me love right. know what's happening. You and your ass invited, so gonna get to clapping. Go pop it for a plan, pop it for me. Turn around and drop it for a plan, drop it for me. I'll rent a beach house in Miami. Wake up with no jammies. Lobster tail for dinner. Julio served that scampi. You got it if you want it. Got it if you want it. Said you got it if you want it. Take my wallet if you want it now. Jump in the Cadillac. Girl, let's put some miles on it. Anything you want, just to put a smile on it. You deserve it, baby. You deserve it all. And I'm gonna give it to you. Gold jewelry shining so bright. Strawberry champagne on ice. Lucky for you, that's what I like. That's what I like. Lucky for you, that's what I like. That's what I like. Sex by the fire at night. Silk sheets and diamonds, all white. Lucky for you, that's what I like. That's what I like. Lucky for you, that's what I like. That's what I like. I'm talking trips to Puerto Rico. Say the word and we go. You can be my frica. Girl, I'll be a frico mamacita. I will never make a promise that I can't keep. I promise that your smile ain't gonna never leave. Jump in the Cadillac. Girl, let's put some miles on it. Anything you want, just to put a smile on it. You deserve it, baby. You deserve it all. And I'm gonna give it.
place okay, it sounds like. Welcome to DP Forum New York City 2023. This is our first one here. Yay, thank you. You can't tell from the photo, I'm Julianne Dressman with Gradle, and wanted to thank Nasdaq. They are hosting this, and it's broadcasted live. And we're at Market Site, this beautiful place in Times Square. Definitely something I never thought I would say in my life. We have something hosted at Times Square. I almost want to be like, live from New York, it's Saturday night. But it's not, it's Tuesday, and we're here to learn about DPE. So we have a great agenda today. So leaders in the field of DPE. Each talk is going to be about 45-minute slot. There's room for Q&A. No breaks, just lunch after Aubrey's wonderful talk. So if you need to do something, take care of it right now. And with that, I want to introduce Hans Dockter. So Hans Dockter is the founder and CEO of Gradle Inc. We've been around for a while, since 2008. Open source product has 35 million downloads per month. And I'll let Hans announce the exciting news. We just had a little bit of a rebrand. So with that, Hans, thank you and welcome.
Thank you. Yeah, so the topic I want to talk about today, so I'm not sure, do we have first the announcement and then the presentation? I'm a little bit. And who's operating the slides? With this thing. Okay, here we go. Oh, okay. So then we start with the presentation. Yeah, we had a hiccup today with the invite. We had, the building is called 151, but the address is 148 Street, and in the invite it says 151. So maybe, I hope for you it was not too painful to find it. Okay, so what I want to talk about today is what I consider the biggest obstacle towards improving developer productivity. And okay, I have to click 2 times now. Okay, so we do regular surveys with developers where we ask them, how much more productive would you be with a more efficient tool chain? And usually more than 80% say at least twice as productive, right? Many claim 4 times, 3 times, 5 times more productive. And this is a gut estimate from developers, okay, but it is extremely consistent. And that is fascinating, right? So because if that is the case, man, we have a big opportunity ahead of us, right? What we can do to almost transform software development, right? If we achieve this mythological, more efficient tool chain, and we will talk about that later, right? So, but the other thing, right, that we know that confirms this is we have a product, the velocity, that instruments the developer tool chain. So we have insight from, a lot of companies when it comes to the tool chain efficiency, and this insight backs this up, right? There is a huge potential in improving the developer tool chain. So, so why are we not investing into this like crazy, right? If someone could guarantee you your developers are 3 times more productive if you do ABC, right? Basically, you get 3x out of your developers. If you were convinced about this, I hope everyone would invest. Like, if you're not investing into this then like crazy, then I don't know what your problem is, right? But it's happening, right? But not happening at the level that I think the potential that we're seeing deserves. So, and what is the perspective of engineering leadership on this, right? So we talk a lot with engineering executives, right? And so first of all, it's very exciting and encouraging to see that developer productivity initiatives are now often supported by executive leadership, right? I would say even 5 years ago, it was often a grassroots movement in stealth mode because engineering leadership didn't care that much about it, except for some of the Bay Area unicorn companies. So that is great, right? That this is happening, and now it's becoming, platform engineers, you have DX teams, all of that. So this is great. So there is some acknowledgement that there is opportunity. But the interesting thing is there is a rare breed of companies that trust the gut of the developers, right? And they make massive investments into that, right? So, and most companies, the investment into DevProd is still far from reflecting what we think is the potential. So, and what I want to discuss today, why is that the case and what can we do to change that? So the goals are aligned. I think it's not a problem with alignment of the goals, right? The developers want to be more productive. They want to create more code. The engineering leadership, that's what they want from the developers, right? More output. So it's the top priority for both developers and leadership to create the output, right? And improve time to market. It's what they're both passionate about. So that's not the problem. The problem, where the misalignment is what they think the impact of DPE and improving the tool chain is, right? So in average, the leadership doesn't feel as strong about the potential, right, of investing into developer productivity and the developer tool chain. And I think the main reason for this is that the developers are arguing from their guts and how they feel about it, and that's a hard thing to communicate to the ones who don't experience it, even if they have been developers in the past, right? So, and there is a lack of models, data, and education that leads to this misalignment, right? So, but one side is very wrong here, right? We're talking about orders of magnitude differences, right? So, and when you look at some companies we're working with, right, the companies at, let's say, at the top of this line, they invest 10 to 20% of their developer headcount goes into supporting the tool chain, right? When you look at an Uber, when you look at a Google, when you look at our company, it's also 10% of our folks working on developer productivity. And then we talk with other companies, they have a DX team of 3 people for 5,000 developers, right? So we're talking about 2 orders of magnitude difference in investment. And do they use different tool chain, do different languages? No, right? The tool chains are pretty similar. That's not the reason for this, right? It's a different perspective, right, on the potential. And again, one side must be very wrong here. I feel pretty strong about which side is wrong. When you look at the success of the companies that are more convinced about that investing into this will be worth it. And Brian, you have some interesting things to share later on about some of the research Microsoft did in this area regarding how important feedback cycle time is. So that will be very interesting. One of the things that is interesting, right? If we show data to the leadership that developers are waiting in average multiple hours a day on feedback, right? And that they get interrupted by flaky tests all the time, they see the value of improving this. No one is saying, oh, making things faster has no value, right? But they are very uncertain. They are very uncertain how those kind of improvements map to business value, right? So I have sometimes discussion where people say, okay, they have to wait for 15 minutes, but they can do emails in between, right? And I'm like, well, do you think it works that way? Do you think that's a productive way of working? And this is a regular thing I hear, right? There is a lot of doubt like that if we reduce wait time for developers, that this will actually results in business value because, we can all do multitasking and things like that. So, and when I tell developers, I usually don't do this, but I say, hey, you know what your boss just told me, right? That you can do emails while you're waiting for 10 minutes. They're freaking out. They say, how can someone think that you can be productive that way? So it's fascinating, right? Those 2 different worlds that we're seeing there. And one thing we also learned from quite a few surveys we did or partners of us did is that developers mentioned their lack of being able to make a business case is the biggest impediment of getting more funding for developer productivity, right? So, and I think those leadership doubts are understandable, right? It's their job not to be driven by the guts, right? They want to see a business case, they want to see something quantifiable. So what do we do, right? So to look at this in a very unromantic way, right? I was a developer, and at the end of the day, developers are production resources, right? And to be more precise, not our feet, not our biceps, right? But our brains. And in a figurative sense, also our hearts. And so you have now 5,000 brains, or 10,000 brains, or 1,000 brains. You're paying a lot of money at your disposal. And you want to maximize the output in code and innovation and business value from those brains, right? And in other industries, be it automotive or chemical, people who are responsible for the production resources are experts in two areas, right? When I have this role in the in the car industry, I'm an expert in cars and industry robots, right? Or in chemistry, I'm an expert in chemistry and chemical apparatuses at scale, right? In our industry, usually the engineering leaders are experts in software, but not in brains, although those are the production resources. And I think this naivety about how the brains works leads to a perspective, oh, they can do emails while they're waiting for the test to run. And this, I would call pedestrian, superficial, kind of naive perspective is one of the big blockers, right? For those companies to be more convinced to invest into the productivity of the developers, right? So it's the gut feel of the leaders versus the gut feel of the developers. And we need to have a more scientific approach. And yeah, I have to operate 2 slide decks. It's the first time in my life, and I'm not doing a good job. There's so much scientific insights into how our brains work, right? It's called cognitive science, a well-established science, and I'm convinced engineering leaders need to dive deeper into cognitive science and how it applies to software development, right? For me, cognitive science is the key to translating the gut feeling of developers into something that doesn't need to be experienced to be believed, right? So let's get started. So cognitive science tells us that there are 2 types of cognitive work, right? And at the bottom, I share some links to the scientific papers that my comments are based on. So if you're interested, right, there's great material out there, and it's a fascinating discipline. So cognitive science tells us there are 2 types of cognitive work, right? The first is learned effortless routine, right, where input is routed through established neural pathways to achieve a certain, right? It's, I'm standing at the street and I need to look left for whether a car is coming or not, right? I don't have to think about this, right? And the second are tasks that require cognitive control, where you have inputs and a goal, but your brain needs to figure out the actions to achieve this goal, right, without having established neural pathways. So an example for the first category is when we walk through a forest, right, and we do not run into trees. That's pretty complex to do. This is not, but we're not getting exhausted by that cognitively, right? Another example, if you're a professional chess player, right, the opening of a chess game, right, that falls in that, most of the time in that category, right? They have established neural pathways, they have the whole opening library in their head, right, for most of the opening combinations. So they can do this 10 hours, 15 hours, they're not making mistakes. As a chess game progresses, the space of possibilities exponentially increases, and you can no longer rely on learned routines. And you need to switch to cognitive control. You now need to figure it out yourself, basically, depending on the concrete situation. So this is where most of the games are won or lost. And it's a separate part of the brain that is responsible for tasks that require cognitive control. It's the prefrontal cortex. And now comes one of the most important things for today's keynote. It's cognitive fatigue, right? Activities mental activities done with cognitive control lead to cognitive fatigue, right? Learned effortless routine you can do for a long time. Things under cognitive control, at one point you are fried, or whatever terms we use in common language to describe that, right? And cognitive fatigue is the major reason why your organization might be far away from delivering the amount of software and innovation, right, that you potentially could. So let's start. And if you look at professional chess players, for example, right, after 4 to 5 hours, right, that's when they start making mistakes they wouldn't have done when they were fresh, right? So when they have to play 2 games on a day, a long game, that's almost impossible for them to compete at a high level, right? Because of cognitive fatigue. There is some biological basis for cognitive fatigue. It's still discussed what exactly is leading to it, but it's a fact, right? It's well proven at a certain point in time, right? Your brain doesn't work as good anymore for anything related to cognitive control. And cognitive fatigue is where you want to be as a company, right? Is that your developers, after, I don't know, 8 hours, right, stop their work and are cognitively fatigued, but that fatigue has translated into a lot of lines of code, right, or innovation, into productive work, right? And the reality is that a lot of the cognitive fatigue that is happening with the developers is not necessarily because of productive work they're doing. And that's what I want to talk about over the next slides. So first, I want to talk about the multitasking myth, right? Many people in leadership, we talked about that, right, have to, you know, they have certain ideas how developers could multitask without losing their productive potential, right? And one reason is they have to multitask a lot themselves, right? So, and many people think multitasking is a skill that can be acquired. Many people claim to be quite good at multitasking, right? For some, it's one of the most important skills in today's work environment. Some say women are better at multitasking than men. People think the younger generation is particularly good at it, and it comes naturally to them. None of that is the case. None, right? There are many, many studies around that, right? You give multitasking group different tasks to accomplish and compare their result with another group that was instructed to do only one thing at a time, and the outcome is unambiguous. The productivity of the multitasking group was lower by a lot, and not only the quantity, but also the quality of their accomplishments lagged significantly behind that of the control group, right? At the same time, the multitaskers, they were asked about, hey, how you were doing? They said, we were great, we were very productive, right? So, and multitasking has many forms, right? So there is this multitasking, you're actually doing things at the same time, but what is very similar is you work on a certain area of the code, you wait, then you run the test, you do something else. It's, you know, so when you switch between activities with a high frequency, that's a very similar pattern for your brain than actually doing multitasking, doing things at the same time, right? Which the brain anyhow cannot do. It's anyhow switching very fast behind. It can never work on 2 things at the same time. So, and why do particular leaders think they're particularly good at multitasking, right? Or you can learn to be good at multitasking. The first reason is there is the lack of control group on objective external measurement that provide us with the feedback, actually we were not that productive, right? Doing things in a multitasking way. And the second is what psychologists call the mere exposure effect, right? So doing something all the time makes us believe we have become good at it, right? So, and completely independent of our actual performance. It's fascinating, right? So, so we tend to confuse familiarity with skill, right? And this is where the gut feel of the leaders often heavily collide with the gut feel of the developers. The leaders are convinced, oh, they can multitask and they're as productive. That's what I'm doing every day, right? And developers are like, man, this is killing us, right? We cannot be productive that way. So Developing software obviously requires cognitive control and induces cognitive fatigue, right? Not all of it, right? Trivial refactoring does not require it, but definitely the parts where we paid what we're getting paid, right? And cognitive fatigue is the reason why the potential of DPE is transformative and not incremental, right? In many of the naive and wrong mental models I encounter with leaders, cognitive fatigue is not present, and therefore they only see the incremental value of DPE, right? So let's talk about the value of DPE when it comes to cognitive fatigue. So the big goal from a DPE perspective is simple but hugely powerful and transformative. So the first is less non-productive time, right? So hold on, something is wrong with the slides. Okay, less non-productive time, that's pretty obvious. Hold on. That's pretty obvious, right? So every time where developers wait for something, right, and not do anything else, right? That is time that hurts you, right? And we want to lower any kind of unproductive cycle time. The second is a lower percentage of the work done under cognitive fatigue, right? So that is, can you remove disturbances in the day of a developer that lead to acceleration of cognitive fatigue, right? Those are the two things that we want to improve with DPE. And so let's talk about what we have to do to achieve this, right? So one thing is that leads to non-productive time is troubleshooting time of code verification failures. So you have a test that fails, and the test indicates that something is wrong with your code. The tooling is not very good today to make it easy to understand what exactly is the root cause of why my test is failing, right? And this starts with a big problem many companies have. You have a failed pull request build, right? And very often you're not sure, is it my code? Is it flakiness in the CI environment, right? It's a big problem to even figure out, right? Even the type of failure, right? Is it a code verification failure, or is it actually a flakiness in the tool chain, right? So the other thing, obviously, we want to improve is feedback time, right? And the third thing is the frequency and troubleshooting time of toolchain failures, right? So for me, one of the things that indicate the immaturity of our industry better than anything else is you have a failed pull request build, you don't know why it's failing. What do most of your developers do? What are you doing usually when this happens? You rerun it, right? So, and you might rerun it twice, you might run it 3 times, right? And then, let's say, the third time you run it, right, it's green. You say, great, I can merge my code now with the master code base. But now, first of all, you run the damn thing 3 times, right? That has wasted compute resources, it has wasted your time, has interrupted you. Secondly, you might have shipped flakiness not to your customer because you don't know, is the flakiness in your tool chain or is it in your product, right? So you make a big guess here, right? And there's interesting research. Spotify did some really interesting research in their app where they can see the areas of the app that is unstable is correlated to the areas where they have a lot of flakiness in their testing, right? It's super interesting, right? So, so the quality of the signal is not good at most organizations, right? And that is very frustrating developers, and it affects, and it's very wasteful, right, for the developers' time, and it affects the quality of the code you're shipping. So code verification failures, right? They are, first of all, they are great, right? That is why we write tests. So from a DPE perspective, we want to have them, right? If someone is telling me, usually we see 20% of CI builds failing, right? That's kind of an average number that we're seeing. And sometimes, I will never forget, pretty well-known tech company, we saw they only have 1% failed builds, right? We talked about that story yesterday. I said, I think you have a problem with your test coverage, right? But what the guy told me is, we only hire the best developers. That's why that number is so low. Okay, well, what can I say, right? So they are great. That's, we need them to get the quality of the code that we want, right? The only thing we can do to avoid unnecessary cognitive fatigue is when it's hard to figure out the root cause. Make it easier to figure out the root cause, right? So feedback time is very interesting, right? That's where we have a lot of discussion. So what people have to understand is that feedback time is strongly correlated with task switching. So what you commonly see is that feedback time shorter than 10 minutes, people are not switching to a different task. They might, well, at least not to a different productive software development task. They might start reading the newspaper or whatever, right? But they wait until they get there, until the feedback cycle is done. And that's really important to understand, right? Wait time is a strategy against task switching. They're not waiting because they're lazy, right? They want to get their stuff done, right? They're waiting because they know it's not worthwhile to switch, right? It's cognitively, it's an effort to switch. I'm not paying that tax, right? When something is faster than 10 minutes, right? So that's very important to understand. They do not enjoy waiting. It's an active decision to avoid task switching. So if some engineering leaders naively think that wait time can be used for doing productive work, they're completely missing that point, right? And that's a discussion I frequently have, right? From a developer perspective, it's an optimal productivity strategy to wait. Sounds funny, but that's the case, right? So obviously, reducing this wait time here is gold, right? Because there is really downtime, right? When you get this down to 5 minutes, right, you get a lot of resources back. Let's say when your feedback cycle time is 10 minutes. With longer feedback cycle time, waiting has become less and less the optimal productivity strategy, right? And that usually, Google did some studies around that, happens at 10 minutes, right? When you see a big shift where people start doing task switching. So they start working on multiple tasks in parallel, and the longer the feedback cycle time, the more tasks they will be working on in parallel. The more tasks in parallel, they more often get interrupted by two-chain events, right? You work on one thing, do the pull request, work another thing, do the pull request build, then you get an error here, a flaky test there. So it's much more jumping between different activities, right? And now, the very important point is that every task switching event, and there's a lot of science around that, accelerates cognitive fatigue, right? So let's say if you have 10 features to finish on a certain day, right? And you do it one by one, you get this done, and with a fast tool chain, you get this done in 8 hours, right? If you have to develop the features by constantly switching back and forth, you will only get, I don't know, 3 or 4 done, something like that. That's how it works, right? And again, there's a lot of science around that, because at one point you can no longer think. And the switching between tasks is accelerating the point when you reach the point, your brain is no longer basically functional for working on those features that you need to finish, right? So again, if there were no cognitive fatigue, task switching would be inexpensive, and feedback cycle time can always be used productively, but that's not the case. And there's tons of research out there, right? And I talk with so many engineering leaders, and they're like, they don't really get it, right? So, and it's not a subjective feeling, right, that developers can just overcome it if they try harder, like the kind of hardcore idea of Elon Musk, right? You can just work harder, right? It's like when your muscle is exhausted, it's a biological fact, right? And cognitive fatigue is a biological fact. There's nothing you can do about it, right? So that is why feedback cycle time is such a critical metric, and people are so vocal and frustrated about it, right? So toolchain failures, they're terrible for many reasons, right? But most importantly, every toolchain failure, a flaky test or some other flakiness in your toolchain cause task switching events, right? You finished your feature, the pull request build is running, you're working on a different feature, now you have a flaky test or some other flaky incident. It forces you now to look at it and see what's going on, right? It forces a task switching event. And it's particularly bad as the problem is not even in the code base, but in a different domain. You now need to understand why is Artifactory down, or you know what I mean? So it forces you to think about something completely different. And furthermore, troubleshooting them, it's not just that you pay the task switching cost. You then also need to pay the cost for figuring out what is the root cause and how to fix it. And this troubleshooting time is zero productive time, right? You don't want to have those kind of failures. So, but most organizations have a lot of them. So there's some confusion around task switching and multiple streams of work, right? So for me, it's completely fine to have multiple streams of work, right? An author, a book author, will most likely work on multiple manuscripts over the course of a week, a month, or a year, right? You're kind of stuck with the first chapter, you thought about it, you kind of say, I need some break from this, and you work on something else, right? This is not task switching. This is just multiple streams of work. That's how I think most knowledge workers are working, and that's a good strategy, right? So it's nothing wrong to work on multiple branches, right? If you can decide when you want to switch based on your mental processes around working on these features. But when you're forced to switch, that's where we talk about task switching, right? So one important point I want to make is cognitive fatigue in innovation, right? So first of all, how do they measure cognitive fatigue in the cognitive science experiments? How do you know someone is cognitive fatigued, right? They found that asking someone whether they are fatigued is not a good metric, right? So fatigue me? Never, right? So what they do is they offer study participants low cognitive costs, low reward tasks, for example, money, right? There's something very simple you can do, you get $1, right? And then there are high cognitive, high reward tasks. They are cognitively more challenging, you get $10, right? So, and the way they measure cognitive fatigue is that when cognitive fatigue sets in, that's when people move to low cognitive cost, low reward tasks and avoid the high cognitive cost, high reward task, right? And what does it mean for software development when you have cognitive fatigue, right? There might still be a lot of development activity when cognitive fatigue sets in. People, if they're fatigued after 4 hours, they not go home, right? They will commit, they will do all kind of stuff, but not high cognitive tasks, right? So you see a lot of activity, right? All the typos you want to have fixed in in your documentation or whatever, right? But that's what you're getting, not more. So companies that have a tool chain that accelerates cognitive fatigue are lowering their capability to innovate, right? Despite everyone working a lot. So all this productivity paranoia, when you look how often do they move the mouse or click or commit, right? The activity numbers again are very high, but the outcome is very disappointing, right? Compared to your competitor who might be in a much better spot when it comes to that. So now imagine a future where the lower cognitive tasks are done by ChatGPT or generative AI, right? Now, because even the companies where cognitive fatigue sets in very late, the developers still have to do the low cognitive task, right? It's still something that needs to be done, right? But in a world where this doesn't need to be done anymore by humans, now the competitive advantage for a company where the developers reach cognitive fatigue much later is scary. If I were a company that has a tool chain that gets my developers very quickly into a cognitive fatigue state, right? And so something to think about. So because of the cognitive science behind what an inefficient tool chain does to the mind and the brain of a developer and the output it produces for you as a company, right? That is the reason why investing into the tool chain is transformative, right? And tool chain efficiencies, we see this over and over again, easily eats up 50% of the developer output, and often more than that, right? It is, the gut feel of the developers here is correct, right? And you're ignoring that at your own risk, right? And there are also many second-degree benefits: less burnout of the developers, less churn, less frustration, happier developers, right? Code that is tested more often, higher quality of software that you're shipping, right? But without a conviction in this, right, that this is actually the case, you will continue to underinvest, and you will not see the results that you could see. So I skip the next slide in the sense. So one thing that we have on our website is the DPE maturity model. Don't have time to go through this today, but it might be interesting, right, where you see yourself as a company, right, on those different levels of maturity. So one of the last things I want to talk about is what I see over and over again is that DPE initiatives are only happening because of the heroics of some individuals. They do this as a side job because they care so much about it. And when I look at our company, right, every function in our company that relies on heroics makes me very nervous, right, and is a red flag, right? That's a fragile state, right? And if that is happening in an important area, right, then it's like we have to do something about it. So those heroics are, sometimes not even appreciated, but even if they are appreciated, but there is a lack of conviction that will lead to not turning this into a sufficiently funded practice, right? That's what we often see. And at one point, the hero is exhausted, right, and thinks, hey, there are other companies who appreciate what I'm doing here much more. Maybe it's time to move on, right? And those are the people you usually don't want to lose, right? So one of the last things is that is a variation of that, right? So in a way, because we are so early in taking developer productivity engineering as a discipline serious, right? There are so many low-cost, high-reward opportunities in your tool chain, right? Who of you is using even a build cache, right? Or who of you is using AI to avoid executing unnecessary tests, right? Who of you has a good flaky test detection process and mechanism? There's so much easy things you can do that are low cost, high reward. It's like, I compared to when we started to get SSDs, right? It's just a no-brainer. It's so easy, right? There's a lot of hard things, right, you can do to improve developer productivity, right? You can go very, very deep. But we are at a point where it's like, hey, you don't even have to do the hard things. There are a lot of easy things. Like it's comparable to getting an SSD into your computer. I mean, who would not be doing this, right? And that's who would not be using a build cache, right? And many still don't. But there's no justification for it. I mean, the only explanation is inertia, right? So this is fantastic because when you start investing into DPE, you can get a lot of quick wins quickly to show, hey, this is worth it, right? But what I see over and over is the following, right? The leadership is often willing to invest into fixing the most burning problems with DPE, right? It's a reactive firefighting mentality, right? We don't want to invest too much into this, but this problem, everyone is complaining about it, so let's do something about the flaky test. But then let's focus on features again, right? And the developers or the DPE teams, right, in those companies, they want to go beyond that. So they hide opportunities that are low cost and high reward. because they want to use them as leverage to do more strategic work in the developer productivity area. I give you, for example, a concrete example. For example, let's say you have a Maven build that is very I/O heavy, right? And creating the archives takes a long time, right? Because of the way the Maven assembly plugin works, right? It's a very concrete example, right? So you could now migrate to Gradle build tool or other build tools, for example, that would fix it, right? But there is a 2 order of magnitude cheaper fix, right? You could write, you can improve the Maven assembly plugin, right? But what teams often do is they tell a leadership, well, the only way we can fix that problem is to do something more strategic, migrate, for example, to a different build tool, what we always wanted to do. Or you want to move from Gradle to Maven, I don't care, right? But they're afraid if they give away that leverage and say, oh, let's quickly fix that I/O problem with Maven, that then the leadership says, okay, now let's not talk about strategic stuff. So the problem of that behavior is that you could do something that gets your feedback cycle time down from 15 minutes to 5 minutes, right, within a couple of weeks, right? But by using this problem to sneak in a strategic initiative, like a build migration, you delay fixing this problem easily by 6 months or a year, costing company millions of dollars, because the developers do not trust the leadership, right? They said, hey, we need also the next step, right? So from their perspective, it's the only way to make progress, right? And that's another example for huge immaturity, right, in organizations, right? So if developers could trust their leadership that the DPE investment is a steady and not just a firefighting mode, they would be free to find a much better mix of incremental quick wins and strategic improvements, right? But they need to trust the leadership that they're willing to do this, right? So in closing, right, talking about developer experience, which has become such an important thing for many organizations, you cannot have a great developer experience without a great toolchain experience, right? And that's what DPE is about, right? And the same thing, you cannot have happy developers, at least not the kind of developers you want happy, right, without giving them the opportunity to be productive, right? It's 2 sides of the same coin, right, for developers. Yeah, that's it for today. Thank you very much.
Now we have a quick 1-minute video about the announcement, and then we'll do questions.
Okay,
yeah, awesome.
Birds flying high, you know how I feel. It's a new dawn, it's a new day, it's a new life for me. And I'm feeling good. I'm feeling good.
Toolchain in most of the organizations is fragmented, right? So that's why we're very excited that we can now support a much broader percentage of the toolchain that you're using. And the name, the velocity, is reflecting that. Yeah, any questions?
How do you deal with hidden costs when working with an organization? So if there's one person who does something 8 hours a day, the cost is really obvious. But if they're saving everybody 10 minutes a day, it's worth it, but you don't see the cost because it's everywhere.
Yes, so I would say, okay, so how do I feel about hidden cost? I think the hidden cost is at the crux of the problem. So I always, like to ask when we work with organizations certain questions, even though I know already what the answer is, right? And one question I like to ask is for people responsible for the tool chain, I said, let's assume your code base is growing by 100% next year, and you make the feedback cycle time 10% faster, right? Let's say it's 1,000 developers. This will be, I don't know, millions of dollars, right? You're saving, right? Who will recognize that a lot of work went into achieving this, and who will praise you, right? And the answer is very clear: no one, right? No one will recognize that, and no one will say, great job. And no one will say, well, maybe we can get it down by 30%, right, by in doubling the investment. And the problem is because there's no data out there, there's no instrumentation. People, so they're not ignoring it by choice, there's just no awareness that this hidden cost exists, or this hidden savings, it's the same thing, exists. For me, that's one of the most important problems, right? I mean, and it's at a point of a caricature, right? I mean, when organization started to introduce ephemeral CI, right, to have more stable CI build pipelines, right? All these people, including kind of very high-profile Bay Area engineering companies, saying, well, now all the developers reaching out to us, the CI team, right, that the CI build times are now much longer because you have to re-download all the dependencies all the time, right? And yeah, we don't know what to do about it. And then my question was always, well, what is the average time now for your dependency downloads? I said, don't know. Right? You don't know, right? So you have all this discussion at the organization, right? And you don't even know how much longer it takes because of that, right? And then you have decision paralysis, right? If you don't have data, everyone has an opinion, everyone has a gut feel, but there is a lack of conviction and nothing is happening. That's why before you do, I feel very strong about that, before you do any investment into your developer tool chain, instrument it. That's the first thing, right? Because it's like performance optimizing code, right? Without profiling. Everyone has hypothesis why a certain area in the code is slow, and all those hypotheses are wrong. Usually, when you do the profiling, you see, okay, it's for that reason, right? Same with the tool chain. So the hidden cost, it's the big problem, right? That's, I think, a key reason why we're not making investment, because we cannot quantify it, right? And it's all those things, right? When you look at we had this a lot with regulated companies. The virus scanner is scanning the build output directory, right? And the build times are much longer because of that. Developers are complaining about it, but it becomes kind of a whining competition, right? Because you don't have data. But if you can say, hey, look, we have data, people don't even know how often they run their builds. But if you notice, hey, we run this 50,000 times a week, and it makes this 3 minutes longer, then it's no longer a whining competition, then it's a business case, right? Again, but you need the data, right? Or should we, not sure, Brian, what do you think about it? Windows I/O speed, right, versus Linux or Mac disk I/O, right? We have so many discussions about that. We need new machines because of this, because of that, but no data, right? It's completely gut feel, and if I were the decision maker, I would say, look, sorry, I don't feel comfortable investing 1 million in new hardware when you cannot quantify the savings that we're getting, right? When it's just a gut feel. Yes, please.
Great presentation. I do have a question. We do know flaky tests really do affect our productivity, but I'm wondering, what is your recommendation on best, let's say, test average? Is it 70%, 80%? What would you recommend?
Recommendation on what? On best?
Test coverage.
Oh, that's a...
I know it's always a bit
yes.
active discussion.
I mean, 80% seems to be what quite some organizations are doing, but I'm not sure if there's any science behind that, right? And then, what is the quality of the test, right? So for me, test coverage is only one part of the equation. What I want to know is how many bugs made it through the test into production, right? And then, and if I have a low number of bugs with 1% test coverage, right, unlikely, right, I'm very happy. And if with 80% a lot of bugs make it still into production, right, then the quality of the test is not correct. So I don't have a better answer. Anyone else has a good answer on that? Could you take the microphone?
For our maintenance and for our testing, we generally do the 70%.
75. Okay, great. Oh, okay.
Maybe to answer that question a little more is you want to spend 20% of your time covering as much. So it's like that 80-20 ratio that you try to invest in. And like trying to cover this extra 20% is going to take you a lot longer actually. So that's why probably the ratio is around that 70-80 that most companies adhere to.
Great.
I have a question, but is it on? Yeah. Just in terms of test coverage, I think it should be more than 0, less than 100%. But so my question is, what is your views on a central DPE team that handles everything for the full org versus freedom of every developer to do their own optimizations? Because sometimes the benefit of a central team can be huge, but at the same time it can stifle innovation and small optimization from individuals.
So it depends, of course, a lot on the, it's a great question. It depends a lot on the structure of an organization. If you are a single product company, right, you can do a great job, right, with having a team that is responsible for CI, for build, a single team, right, for everything regarding the tool chain, right? And because that team is embedded into that one product that you're shipping, into this one engineering team that you have, that works great, right? But of course, most companies here do not live in that world, right? They have a lot of products, they have a lot of teams, so that is and then it becomes interesting, right? What is the division of work for developer productivity? A centralized team, let's say for a large bank, cannot own every productivity aspect. It's just completely important. There's so much specific stuff, right? The teams know about what they need, right? There need to be some role in the application teams to improve the toolchain efficiency, right? But you absolutely need a centralized team, right? That provides infrastructure and services, right? Like build caching, predictive test selection, test distribution, right? Make sure CI is rock solid, right? Make sure that you can efficiently troubleshoot problems and can provide you with benchmarks. I think that's very important for an organization, like that you have a centralized team that has observability to say, okay, we have 200 engineering teams, right? One engineering team, they're running 30,000 build and test cycles per week, the other only 500. This is what's going on here. Or the other has 10 times more flaky tests than the other. So I think benchmarking when you are at that scales is super important too. Because I think teams are, you need to give them freedom in such a context to make the decision, but there need to be some guardrails, right? And what we see at the moment is the teams feel like, well, we don't care, we do whatever the hell we want. And then for a centralized team, it's very hard to put organizational pressure on them. But when you have some benchmarking, you can say, well, you do whatever you want, but look, you have 10 times more flaky tests than everyone else in the organization. We don't feel like that's completely up to you to work that inefficiently, right? But again, you cannot own every build for 5,000 teams. So, So it's a separation of work, but you need to have a strong DPE team that has strong observability, right, to report which teams are doing better in these areas and others, right? So not so much to take out the stick, I would say, but to provide learning opportunities to show them, hey, here's what other teams are doing. You can also do this if you invest a little bit of time into this. But you cannot fix their flaky tests. They have to do this, right?
Hey Hans, great presentation.
Thanks.
I'm curious to get your thoughts on, like, if you think it's possible to measure developer productivity accurately. Like, I noticed there was quite a big backlash in the developer community around McKinsey's article, yes, you can measure software developer productivity. So if you believe that it's possible, you know, like what metrics should we be looking at, and how can leaders, you know, collect benchmarks that's not threatening to individual software developers?
My perspective is pretty simple, right? What you can measure pretty precisely is the hidden cost, is the inefficiency. When someone is waiting for 10 minutes, right, you know that person is not productive, right? So basically, what you can measure well are all the obstacles to developer productivity that comes from the tool chain, right? That is something you can measure. And the good thing is now, and Brian, you will talk about that, right? That I think we really need the big fours to help the industry, right? Because they have the skill set to and the ambition to, with their hundreds of thousands of developers, to do a lot of interesting research, right? So, and so again, coming to this hidden cost, right? Microsoft has evidence, right, where they say we have strong evidence that if you improve feedback cycle times, we get more code, right? So basically, the whole thing, tool chain to business value, right? So that is for me the most obvious one, right? The obstacles that your developers have, they are pretty easy to measure them and remove them, right? And you will have more productive developers. There's no question about it. How to then measure, let's say, individual productivity of a developer? That's not that is very. I don't have the only thing I would say. We rather have a team perspective and not an individual developer perspective, and the toolchain measurements can give you some indications that the team is not productive for whatever reason, right? So at the keynote at the DPE Summit, we looked at the example of knives in meat processing plants, right? And knives need to be sharp, right? But they measured the sharpness of the knives in those plants, not just to make sure that they always have sharp knives, but what they learned is that the not so skilled workers, the knives get blunter much faster. So they used the measurement of the sharpness as a training opportunity, right? If one operator loses the sharpness of the knife in 1 hour and a better one, it takes 3 hours, right? Say, okay, you need to learn how to cut better, right? So the same thing, we can use flaky tests. We can use very important metrics some people are now using is how often people ask for feedback, right? As a maturity indicator for those teams are usually more productive than the other teams, right? So the tool chain gives you indications that that certain teams are not so mature than others in terms of how they interact with the tool chain, right? And anything else, what you can do to measure productivity developer, there are people who are thinking more about that. Brian, what is your perspective on that?
My perspective, stick around for the afternoon session because I'm going to tackle that question head on. That's what my session is all about.
Great. Okay, I think I took a little more time than was allocated to me, so thanks for the great questions and looking forward to the next talk.
Hans mentioned the DPE Summit. That was an event we had a couple weeks ago where about 500 developers we hosted. And they spent a whole day tackling what do we measure in developer productivity. And the answer was it's really hard. No one's figured it out yet, but you got to keep trying, and we're doing it. So I'm really excited to introduce the next speaker. You heard Hans talk a lot about what's the theory and science behind developer productivity and why is it really important. But what does that mean in the real world for you all? So up next, we have Amado Gramajo. He is the Vice President of Infrastructure and DevOps at Nasdaq. They've been generous enough to bring us to Sweden a couple times. We've got to see what their developers are doing there and here in the US. And with that, he's going to be talking about DPE in the enterprise. Thanks so much, Amado.
And then is there a red button to go backwards?
We'll get started in a second.
who my number is he? 12. 12.
All right. Hello, everyone, and welcome to the Nasdaq market site. Nasdaq is ecstatic to host the first New York City DPE forum in New York City. Very exciting. A little bit about me. So I've been at Nasdaq for about 3 years now. I came from like Goldman, JP Morgan. I've always been in enterprise, but I do have a confession. I am not a developer. So I've always been in infrastructure. I've always been in operations and engineering since 1990, probably. And I've always worked with developers. So here's a brief agenda of what we're going to discuss. DPE defined. For those that don't know, and people maybe in operations don't realize what it means, we'll cover it here. Some challenges, and then we'll have the operations focus. More challenges as it relates to operations, and then finally, we'll review a solution based on DPE and what a systematic approach to developer velocity looks like for operations. Okay, so DPE defined. So before I start here, I had a different presentation in mind, but then I had a conversation, several conversations actually with Hans. And if you guys haven't talked to Hans, I highly recommend you talk to him. His energy is infectious. His energy, his passion for what he's doing, it really resonates. So I kind of like shifted what I wanted to do and apply the parallels of what's trying to be accomplished with DPE to what we're doing in the operations space, because they're very similar challenges. They're very parallel. So this quote here, developer productivity engineering is software development discipline used by software development organizations to maximize developer productivity, happiness through acceleration technologies and analytics on every CI and local build. So for this, this quote, and it's from the handbook. If you guys haven't read the handbook, it's the 2nd edition. Happiness here is to me the key, right? And happiness can mean a lot of things to different people, and especially with developers. But in the context of DPE, happiness for developer is unlocking their creative flow, letting them develop and push their products out, stable quality, stable code, stable deployments. Happy developer means that they have good software. Happy developer means that they're going to be nice to ops, right? That's us. And this, to me, was also key. A practice, not a new phase, right? So this is our typical, right? I mean, it's changed, hasn't changed much in 10 years, right? We still have code being committed, we still do our testing, we're still doing CI/CD, and we're still deploying software, and it's usually operations that deploys the software, right? What I liked about DPE was that it's still all this, but right now in its current iteration and the discussion and the research that we're having for it and the tools that they're building for that improvement is focused on build and test, right? So you're getting all these benefits in build and test and CI/CD. You're getting introspection, observability, you're caching the insight, all that's happening here. But for me, as I'm operations, I'm interested on this side of the diagram, because if you think about the last 10 years, the trend has been kind of focused here with Terraform, infrastructure automation, infrastructure as code, deploy fast, deploy often. But now that, that's not as shiny anymore, right? It doesn't really do much for that side of the stack of the SDLC, because here you're just deploying your software, right? And that's fine, you can deploy fast. Everyone's figured this out. Here, with the build and test, that's how you improve the quality of your software, right? That's the real value, the real business value in the SDLC happens in these two sections here, because you have better software, you have a competitive edge over other companies. But what's happened? So as new technologies have sprung up, cloud, Kubernetes, in enterprises specifically where you have dedicated teams, cyber, InfoSec, internal audit, infrastructure, so many teams that have one function for a specific reason, for a purpose, right? It's not a negative thing. you're getting way more controls, way more guards and guardrails that are kind of slowing the velocity that we saw that the developers had initially when, like 10 years ago when everybody was able to spin up their own cloud account and we had a product-centric approach. Now it's kind of shifting again back to a more, I think you mentioned, like centralized, like all of a sudden, hey, we probably do need something, we do need DevOps centralized. I'm not for centralization, and I'll talk about it, but here, dev teams expand, code bases bloom, repos increase in numbers. This is directly from the handbook, and I love that code bases bloom is so beautiful. But you can visualize it, right? And the challenge is, we still have to keep governance, compliance, and security, and also still be fast and still automate, which is very difficult, right? We all know the, pick one triangle thing, and you can't have the other two. Pick one of six, and you're not going to have anything else, right? It's a challenge. So this is where IT operation comes in. Da-da-da. So what I'm seeing in other Nasdaq as well, other organizations is, some teams, some development teams, especially when you have hundreds of products, thousands of developers, you have different skill sets, different capabilities within those development teams that can't pick up and continue the work of security, get this STIG done, right? Or add this module because it isn't resilient. It's the context switching. All of a sudden, a developer who is working on his actual product work that he gets paid for is switching and trying to figure out, well, how do I fix this EC2 module, right? And that's creating friction between the development group and InfoSec and cyber, right? Same thing with even like the platform engineering team that owns cloud or whoever owns cloud in the organization. Whenever they make a change to a pipeline, we need you to rebuild, use this new pipeline, or you can't use this new pipeline, use this new account. They're like, what the? And it's you, it's on you, developer, because you own the account. It's like context switching to the extreme, and developers get mad, right? So that creates all this friction. But what we've been doing with IT operations, we kind of sit in the middle of everything. So I manage infrastructure, observability, and DevOps engineering, and the DevOps engineering team is responsible for deployment of the platform for all the exchanges around the world. That's over 130 markets that we support. The way we've been working is trying to step in and not be a centralized team, but provide a shared service that's available to all developers so that we can pick up all the slack that they don't want to deal with, that cause them friction, and enable them to continue on their path to whatever their velocity is, right? So it's a matrixed org, and it's overlaid over different types of teams that are siloed, but we're all operating as one, and it's global. Where before, like you had the US team doing something, then you had like EMEA or Nordics doing something else. And we stay with our principles, because IT, on-prem, ops, these are kind of like our mandates: resiliency and availability, manage, reduce costs. We're bringing those to whatever platform or technology development uses. And they're very happy about this, which is good. But IT itself, IT operations, has many of the same challenges that the developers have. Talent acquisition, skill sets, it's very different. Even internally, you can train one individual, he'll pick something up, you train another individual, he may say, why am I getting this training? I'm not using this. Another guy learn a little bit, then he'll forget it. Right, so it's different capabilities. It's challenging, there's really no solution for it, but the resources are so scarce for those bodies that you have to maintain your existing teams, and you don't want to risk, people, this lady's looking at the airport, it's a missed opportunity. You don't want them to get sad and say, hey, why am I not part of this? You are part of it, and it's trying to set up and change the mindset of one that was, operations-based, where you're just working on tasks and learning from the way our developers are working, which is more engineering-minded, more innovative, right? Instead of waiting for something to happen, you start thinking about a solution for something, right? Not just fixing, but what's the actual solution for it? A very particular set of skills. Where's this from? Anybody get it? Anybody get it? Airport? Yes. That's the other issue, right? So infrastructure, by its very nature, and to its strength, is very siloed. The storage dude is going to work on the storage team. The IDM guy is going to work on the IDM stuff. You know, the Windows guy is going to, because they have that institutional experience and expertise for that product. But they also want to learn, and the capabilities that you're seeing now, like, are becoming standard. They're making their way into the products they support. So now, like, products are supporting Terraform, they're supporting automation. You can leverage Python from stuff. Something was like on Rust. So now they're realizing that, you know, they're not just these admins, they're also engineers that can code. So having this shared service function versus centralized is helping them grow and level up the skills. And as that happens, they start working more and more with the developers to help the developers solution any of the friction or the problems that are coming outside of their development of code, right? Because they own their environment. And if it has to be updated, they'd rather work on their code than update that environment. Because the fun stuff has happened already, right? We've already learned Terraform, now it's a pain in the ass. Kubernetes, who the hell is going to manage that? So you manage it. You know, like, we're all done. Docker, no one even talks about Docker anymore. Everybody's like, oh, Docker. Right? Now everybody's like, oh, you take care of it. Nobody's versioning their build. No, you version your build, right? So as stuff becomes normalized, we have to start building operational controls, standardizing so that it can be automated. So that's where operations comes in. Okay. And okay, so this is what I liked about DPE. The approach to developer productivity engineering is a systematic approach. And if you go to a company and they're trying to do DevOps, SRE, you know, whatever, the first thing they say is, well, how do you change the culture? You have to change the culture. You know, you read the books, oh, we have, you know, the 3 waves and then feedback loops and change the culture. But no one ever changes the culture, right? Everybody just talks about it. Like, I mean, like, you look at the signs in front of the elevator, you know, where this is our values, blah, blah, blah. Nobody's changing. Nobody's doing anything. Like, all right. So by leveraging a systematic approach, you're able to change culture. Because if you look at what makes a company defined, it's the way the people work, right? And in a regulated company, and companies that are enterprise, the way they work is based on the policies and procedures. So the challenge is to start looking at the policies and procedures, to start enabling the ops teams to work and operate more like developers. Everything should be an issue. Everything should be code. If it's not automated, why isn't it? Follow up, create a problem ticket. Some teams don't even have like scrums. They don't have Jira. They're using like incident tickets. Incident tickets you close out. Jira issue, you track it, next steps, communicate, you can collaborate on it. So a lot of the things here that are systematic can apply to ops, and it absolutely involves people, process, right? Establishing the process. If you have a pipeline and you're regulated, an auditor is going to come in and say, oh, you can't do DevOps. How do you know who submitted the code? You know, is that the same person that deployed it? If you don't have a control for that, you can't do it. Okay, we'll make a control, right? We'll make sure you create the standard. And that's how you start changing the way you work. All of a sudden, you're operating in a DevOps way, right? The thing that I found is speaking to developers, and it's the same thing with SRE and even platform engineering. All of these things are just like fads and they're buzzwords for marketing. But every developer has a different understanding of what that means. But they have a goal of what it means to them. Like, so if you talk to a developer and you say DevOps, there's one aspect of it that they like and they consider DevOps. So what we try to do is, whatever that we'll interview, like the ops team will interview, say, what are you looking for out of DevOps, right? It doesn't have to be everything, right? Whatever you need, and it will help them get there, right? Because he may not have time to do everything, but he has one piece that he feels will improve the quality of delivery of his software. So that's what you work on, right? Not like, oh, you're doing, there's like this safe agile stuff, like, you're gonna do safe agile, and it's like the antithesis of agile. Like, there's so much bloat. No one hears from safe, is it? No, good. But yeah, and the technology too, right? The technology is very important. The standardization of tools to be able to provide solutions. We have a lot of developers because we went with a product mindset, like the developer should be able to support their own platform. You have very many tools, and you have people recreating the same solutions with different products. And there's no synergy, and you don't have the scale. Having that standardized, which can only happen if you have a centralized place where it spawns and creates practices and areas where you can discuss it, would be like shared services in operations. Observability and automation, I'll talk about new ways of working in a minute. This is key. I mean, this is what, to me, was fascinating about DPE and the build cache. I'm not a developer, but when I started looking at the introspection that you can do in the build cache, I was like, what the hell? This is crazy. But taking that idea and just applying it everywhere, like across the platform, like GitLab itself, AWS itself, you can help troubleshoot and minimize issues that may be infrastructure faster. But you have to work and collaborate with developers a little bit more. But at least now you can have a real conversation versus it's slow, it's slow, it's slow. And I think we had one somebody mentioned, the person just retried. You retried 6 times, look a little deeper. It turned out to be like a firewall teams. No one here is from firewall team, right? Bane of my existence. So the new ways of working, right? For me at Nasdaq, the compelling event was us migrating our outpost, our exchange, to the cloud. So that was like my first month in at the job, and all of a sudden we're like, oh, we're going to migrate to AWS Outpost. I'm like, what's Outpost? The first week I started, instead of having orientation, I had like all these like 6-hour meetings about Outpost. I'm like, what the hell's going on? So finally we announced it was a big deal, and then I had all infrastructure team, DevOps, application management team, and AWS, and we're trying to work together. And of course, Ops doesn't know like Scrum, right? None of that. So we had to like, it was like trial by fire. So we put them all in a room, gave them like stickies virtually, and said just put all your ideas down, take the color, blah, blah, blah. And we had our first like kind of like board, and we prioritized, and we were able to start collaborating, norming, storming, forming, that thing. And then after that, we introduced like story points, right? And then grooming, and then PI, but we weren't so strict with it. Like, if your story point was off, your story point was off, right? If you didn't have anything to talk about in the back, you didn't have it. Like, it was very casual, and it worked. It worked so much that at one point I was like, all right, I guess we don't need it anymore. And then like 2 weeks later, like, hey, are you gonna bring that back for like our regular work? Because they liked it before. When I first tried to introduce it, they were like, oh, we're gonna be surrounded by ticket walls. We don't want ticket walls. And now like, oh, can we have that? Can we have that? Yeah. So new ways of working until they try it. But usually it helps if you have something, an event or something that can trigger that way of working, right? Migrating to a new platform is always a good one. Anytime you introduce a new technology, it's an opportunity to change the way the company works, all right? So I was fortunate to be able to join the Outpost team, actually lead it, because we affect a lot of change, not only in terms of ways of working for operations, but also the architecture of the systems, of the trading system and the way they operate in the cloud, which is amazing that we were able to do it in such a short time. And again, observability automation, this is important. I think it applies to all aspects of technology now, like the insight. There's no reason to have it. AI ops is one thing you always hear. It's, oh, we got to bring this company in. AI ops is so easy. It's right there. Just what are you looking at? What needs to be fixed? Can you loop it? Does it self-heal? Yes. All right. That's AI. It's automated. Done. It doesn't have to be like this crazy thing. The more you do that, you'll see the less and less issues and alarms you have that can actually resolve themselves, right? Let me see. Oh, and that's it. That was the last one. So originally, I was going to have, you see this here? This is like a lava thing. You guys see that? So originally I was going to have like this be all fire and brimstone, right? But of course it wasn't, it didn't get approved because I was going to say, we all know the way the world's going to end. It's not climate change. It's Skynet. It's Skynet. It's AI. And who's writing the AI code? Developers. And it's going to be the developer that's not happy. That's going to... So keep your developers happy, and you know, we'll have a beautiful country that's not blown up. So, thank you. So, any questions? All right. Thank you for your time.
Thank you, Amado. I'm glad I know how the world will end soon. In about a minute, these walls are going to be coming down. And don't freak out. We're not trapping you until you know all the answers to DPE. It's actually just so they can get the food set up for you all. So don't be distracted. And anyone on that side of the wall is not going to make it over. So maybe 5, 4, 3, 2, 1. Come on. Okay. Amazing. I don't envy anyone like Amado's team that has to do DPE in a very regulated environment. It's really difficult to do DPE in general, and that adds another layer. For you, the gentleman that asked, hey, do we do centralized DPE team or different ones? I'm not saying you're going to get the answer, but our next speaker is on the centralized developer experience team at Netflix. So she's probably going to give you a lot of insight into the benefit of what a centralized team can bring. They've been having it for a long time. So with that, Aubrey, come on up, and thanks so much.
Let me get this all set up. Shall I wait for the walls to continue making their way down? They're pretty silent. Yeah. Okay. Excellent. So, hi everybody, my name is Aubrey Chipman, and I'm going to be talking today about how improving testing experience goes beyond quality, a developer productivity point of view of this. So, as you can see here, I'm on the developer productivity team over at Netflix, specifically on the JVM ecosystem team. And, oh, there we go. So I also want to give a shout out to my teammates and coworker Roberto Perez Alcolea. We put together this talk and provided it just a few weeks ago over at the DPE Summit. So today you get to hear from me. Excellent. So first of all, let's go through what we're going to be talking about. We want to know, why are we talking about improving this testing experience? What does it look like in the day of the life of a developer? What context can we take from this day in the life of a developer into the Netflix JVM build landscape? What are some common problems in the software testing experience? How can we go about improving this experience, learnings we had along the way, and then some time for Q&A. So first of all, why are we going to be focusing on improving the testing experience? So here's something that you're probably quite familiar with and heard about earlier today as well. So a flow state of mind is what happens when you're feeling inspired, when you're feeling motivated in the task at hand. You're entering this particular state of mind where you think you can get things done, you're happy to be working on the thing that you would like to work on. One of the things that's worthwhile in pointing out over here is that it often takes a little bit of time to reach this particular flow state and flow mindset. People say it can take 15 minutes, 30 minutes, these kinds of things, but there's a number that works out well for each person. So when you're feeling quite productive, you're getting things done, happy path right over here. Unfortunately, this is not always the case. We live in another area where there's lots of different context switching. Hans especially was talking about this context switching, and it can bring you out of this flow state. These could be things like meetings, responding to messages, triaging a broken build, investigating how to use a tool. So how can we go thinking about this and what it looks like for developers? So at Netflix, we talk a lot about the developer inner loop and outer loop. So this is just a way to break down what are the things that you're doing more frequently versus less frequently, where this outer loop is things like planning, doing your sprint, figuring out what's going to go inside of there, that kind of things. Maybe you're doing on a weekly cadence versus things that you're going to be doing much more often. Things like committing, going through your code itself, running your tests, running your build. These are things you're going to be doing daily, hourly, multiple times an hour. And we want to make sure that this inner loop is what we're really going to be focusing on. So inside of this developer inner loop, what we're talking about today is this testing component where we want people to be going through this loop many, many times, very frequently throughout the day. So testing is crucial in the Inner loop and a suboptimal experience leads to context switching and losing of your flow state. As you can see, there's lots of little alarm bells right there. So let's take a look at the day in the life of a developer. So we're going to hear about things going well and then a low productive environment. This poor person. So first of all, Tuesday afternoon, everything's going well. You're writing some code, you're taking a look at your build scan, everything's going green, your builds are going green, you're deploying over to your test environment, to your prod environment, happiness all over the place. You go home, you felt great. Splendid. Go back into the office Monday morning. Good morning, everybody. Are you ready to pick up right where you left off? Well, unfortunately, that is not what's going to be happening today. So the developer goes in, they see that, in fact, the CI pipelines are red. They pull down the latest code change to go make a fix, and then they notice that actually the project can't be compiled, or the tests aren't passing already. So they dig into the problem, the developer fixes the underlying issue, and then they say, I can finally go back to what I was doing yesterday that I was thinking about, and I'm ready to get going. However, the developer commits the code change and the build goes red. This is most unfortunate. In this particular case, the build has gone red due to a change not related to this developer's commit. They see that this test is flaky. The developer has to go back, fix the flaky test, and then has to wait at this point several minutes or hours, however long it takes, to watch, to sit there to make sure that their pipeline is going to go through and that they can finally get back to working on the thing they were working on yesterday. So it leads to a very unhappy sense over here. The developer does not achieve much. They're frustrated and feeling unmotivated overall. They want to get working on the feature they intended to work on. So this is one person's experience on one particular day. So let's take a look at what this looks like at the overall Netflix JVM build landscape and how this could be amplified. So over at Netflix, throughout the last 28 days, we have 566,000 builds being executed in CI that are running tests, and 256,000 of them that are executing tests over on the local environment. So there's tests everywhere. 14 million of them executed in the last 28 days. So we want to make sure that people who are running these tests are having a nice experience throughout all of this. They're not having that feeling that we just saw. So this talk is going to be about focusing on testing specifically at the project level. What I mean by that is within the bounds of the SCM repository, within the bounds of what is inside of your project and going to be done pre-deployment. There's lots of different kinds of testing that can be done post-deployment, things like canaries, taking shadow traffic, but that's not going to be the focus of this talk today. So some common problems that we see in the software testing experience. What might these be? First of all, you might see that testing becomes difficult. This might be because it's hard to write tests. You're missing tools. You have complex testing setups. Maybe something's not quite right there. Perhaps there's lack of actionable feedback. You see error code 1, or this very helpful, something went wrong, unknown error. That's not terribly helpful. It could be that your test suites didn't evolve the same way as the production code itself. Maybe there's just a lack of documentation. Someone says, go take a look at this library to write your tests, but doesn't provide an example. There's lots of reasons why testing could become difficult there. There might also be issues where there are tests, but they are flaky tests. So what are these? These are tests that fail to produce the same outcome with every single test run. And some potential reasons you might have this is asynchronicity, concurrency. You're looking at the wrong thread. There was a wait. You didn't wait long enough. There could be test order dependent problems. Let's say you're making some validations with a known database state, but a test went ahead, inserted some data, and now your validations aren't passing anymore because of that shared state and unexpected outcomes there. You might have poorly modeled tests. So for this, what I mean is you're depending on a clock, you're depending on a time zone, or you're depending on that shared database state. And the way that it works on your machine is not the same way that it's going to work on someone else's machine or in the CI environment. So some results from having these flaky tests is that this can and will frustrate the developers, yourself, everyone else on your team, and people who are relying on your service. People might, one, delete the test. Well, I guess there wasn't terribly much use there. They might ignore the test and never revisit it, and then it just gets kind of old and crufty. Versus, they might go ahead and identify this flaky test and then fix it right there in the moment. Therefore, it's not a flaky test anymore, and it will help you provide confidence in your subsequent deployments. But Whatever the case, people are going to start losing confidence in this test suite, and they're going to have some feelings on this area you see over here, and it's not going to be the happy feelings. So another issue that you might run into is that there are tests, but they are slow. So this could come in where there's a variety in test setup time, things to take to start up or tear down your resources. There could be shared resources forcing developers to execute all of the tests in a serial fashion. Let's say your machine doesn't have enough memory, and so you can only spin up 3 or 4 tests. You're resource constrained. Maybe there's local parallelization issues, and as your projects evolve, all of these issues are going to become more and more at play because the test suites are growing just like your production code itself. Another problem that you might have is that there are tests, but they are inconsistent. Most unfortunate. So over at Netflix, primarily we develop on Mac machines, as you see right here, but we're running CI over on Linux agents. So you might have missing tools, things that I'm expecting to have on my machine here, they may not be installed on the agents themselves. There might be network access and security policies that are different. For example, there's identity and access management that knows that I am Aubrey, I am running the tests on my machine here. But when I'm running them over in CI, when I'm running them on a different agent, we have to make sure that we're propagating that identity in case I need to make network calls to an application running in the test environment or talking to AWS resources, things like that. So are these issues causing problems in my organization? Well, most likely yes. So each of these can result in some unwanted situations where developers are going to be frustrated, and it's possible to get into these following traps. 1, avoiding writing tests entirely. That is a terrible trap to be in, a terrible situation to feel that you have to be in this position. People might ignore or remove tests in order to verify their changes. And another thing that we've seen people do is avoid running their tests locally and only running them over in CI because they know that in CI it's going to be run stably the same way every time. You're not going to run into that problem about does it work on my machine but not work somewhere else. An extra problem over here is that you can have a queue of execution where all the people on your team are waiting for the CI agents to get through the various builds on there instead of just running it on their own local machines. So this brings us back to the developer inner loop and taking a look at this cycle right here. We want to make sure that we're allowing for folks to be able to commit, run their builds, run their tests, write everything that they need to do right on their local machine and get that feedback as quickly as possible so they can stay in this happy flow state where they're feeling productive, they're getting that feedback fast. They know that the changes they just made are the ones that are going to be showing on their test results right over here. If something goes red, it's because of a change they just introduced. Here's a quote that we like to bring out. This is from my teammate, also on the JVM ecosystem team. He said, "It is staggering how tolerant engineers are of toil and frustration and friction." So people will just be able to put up with a lot as they're trying to get things shipped out and have a sense of confidence. And at Netflix, we are not immune to that. But what we have done is we have invested on it. So let's talk now about how we go about improving the testing experience for developers. So first of all, we're going to talk about faster test startup, and we'll take a look at one real-world example. So this is one particular project that is a good representation of the kind of application we might have over at Netflix. We have Spring Boot, specifically Spring Boot Netflix, which is a wrapper on top of OSS Spring Boot. We have a database component, in this case CockroachDB. We're using test containers for validating against a real database, a real CockroachDB cluster inside of our tests. We're using Juke for type-safe SQL queries, be able to write them over in Java. We have Flyway for database migrations, and here we've got about 35 files with a small amount of DDL that are just setting up the structure, but not actually putting in any kind of test data. So each of these are great tools. Seriously, they are wonderful items to use. However, what we did see is that running a single test class was much slower than we really wanted it to be. For example, this one test took over 2 minutes. When we tried to figure out why this was or what was happening over here, we actually saw that the test method was not the problem. The test method itself only took 1.7 seconds. So there was something else going on. So we wanted to figure out what was actually making this so slow. What were the actual bottlenecks at play over here? We saw that it took 49 seconds to apply database migrations. It took 13 seconds just waiting for this database to be ready in Docker on M1. So each of these items was happening every time we were executing a test that was going through these migrations again, and we had many such tests inside of this project. So the tools were not the problem, it was how we had configured it. It was how we were using these particular tools that was providing this slowness. So we took a look at why this was. We saw that there were many migration files with multiple SQL statements. So those 35 files of DDL that I was talking about, that ends up having a lot of network activity. We saw that we were using Docker with ARM-based Mac, and while it's possible to use Docker on ARM, you're often limited to what images are stable or even available for the ARM architecture. As well, emulation can slow this down. So the version of CockroachDB that we were using didn't have ARM64-based Docker image, which caused a virtualization tax for M1 and Rosetta. We also saw that we weren't reusing our containers. So we were using test containers to be able to test against a real CockroachDB cluster, but we were initializing a container per test, and this can add up and be expensive. So let's take a look, first of all, at the results that we found once we started fixing this. We were able to see that the single test, this total test time for the single test was reduced by 60% after we went in and made some fixes. The test method itself was even faster at 0.6 seconds. When we take a look at the aggregate of all of this, we can see the build time for this project overall, which is taking into consideration all of the tests. Like this is one particular test, this is gonna be all of the tests inside of this one project. The build time dropped by more than 50%. So this was fantastic for us. Happy engineers. So what did we change inside of here? So those 35 files of DDL, of the database migrations that I was talking about, we ended up taking a snapshot and we're able to see what are we expecting this to look like at the end state after running all of these various migrations. We were able to compress it, just have one file, and then have much less network activity inside of there. Another item that we did is started using the test container singleton pattern. So this is where you define a container that's only started once for several test classes. As well, we rolled out Test Containers Cloud. So this is made by Atomic Jar, and it's an on-demand platform for running containers for test containers tests. It removes the requirement of having Docker environment available, simplifies the test for running suites, and make sure that you're running it the same way locally as you're going to be running it over in CI. So some other suggestions that we had for this particular project, and some other ones as well, is to get better at test slicing. So having a reduced application context and reduced data that you have inside of there. A lot of times there's a lot of data that people are working with, and just having less of it is really going to make the test go much faster. As well, with the context initialization, we have all these items running in Spring Boot, and instead of bringing in every single bean that's available, you can define, actually, I just want to test these 5 or 6 ones. This is all that I really need for this particular startup. So overall, investing on this application startup time also helps as well. This can be done with better modularization and trimming your dependencies of what you do and don't need inside of this application. So this was taking a look at one particular project, but you might find opportunities to standardize tools and opportunities like this across various teams. So to give you some more information about the Netflix JVM ecosystem, we have a multi-repo setup, so not a mono repo over here, and we've got 3,400 active JVM repositories. So these are ones that are building, packaging, publishing all of the time, quite active. Teams can have the setup however they like, and so there's not a specific oversight on how to make test performance better. We've got lots of performance optimizations in the application itself once it's deployed somewhere, but for the tests themselves, each individual team gets to take a look at what their tests are looking like and make sure that they're performing optimally. In this case, you could see that there were quite a few low-hanging fruits. We could go and make things go much, much faster. So whenever people ask for assistance, then we have productivity engineering teams that can go help out, take a look at the repository, and see what can we make better in this area. So now let's take a look at some of the other items that we're able to roll out to many projects at once. They can also be rolled out to just one individual project, but we do roll it out to all of our builds over at Netflix. So this one is develocity and flaky test detection. So when a test fails, how do we determine if it's flaky or not? Well, we run it again, as we heard earlier today. And then we run it again, and we run it again. And if finally it goes from red to green, we have ourselves a flaky test. So this is really useful to know, but we still want to make sure that we're tracking this and being able to visualize it. Some more context for this as well is that here's an image that is probably very familiar to y'all. It's the testing pyramid. What I want to call out specifically is at the bottom there's unit tests. These are things that they require low effort, there's low fragility to them. There's a low amount of time that you're going to get feedback from these. As you go higher up this pyramid, you have things like smoke tests, manual tests. At this point, there's a lot of effort to put them in place. It takes quite a while to get feedback. Maybe there's a lot of complex setups. Maybe you've put several assertions inside of there so you can walk some sort of path rather than just making one particular validation. As you go higher up this stack, as you go higher up this testing pyramid, the impact of having flaky tests is going to get more and more impactful and more painful. So, over at Netflix, we want to make sure that we're visualizing on a per project level as well as visualizing overall throughout all of the JVM ecosystem. What does it look like on our suite of projects with flaky tests? So we use Gradle's Test Retry Gradle plugin with Devvelocity to catch and visualize test flakiness. So here is what things look like for Netflix currently. This was from early August to early September. So in this month, we had 5.6 thousand builds, about 1% of all of our builds, that have flaky tests. And this is not great, unfortunately. So here we can take a look at a specific class, which is quite naughty. It has lots of flaky tests over here. And I'm not sure if you can see all the numbers over here, but as we're looking through, we can see that 42 times this passed the very first time that it ran. However, there were 296 invocations that are marked over as flaky, so we were able to have a failing test, perhaps another failing test, and then finally it went ahead and went green. So at Netflix, we have it configured to have up to 3 retries. We decided this was a nice balance between making sure that your builds can go through, let's say over in CI, and you're not just having a red build because of this one flaky test, versus there was an actual test failure and you should really stop the build. It should go red at this point. So even with these 3 retries in place, we're able to see that there are 3 times that this class ran, and even with retry, the whole thing ended up failing. So the build went red, someone needed to go and investigate, perhaps triage the situation, and maybe rerun the build. But whatever they were going to do, they didn't get to continue on in their thought process. So another aspect of looking at it is it's not just that this test was marked as flaky, but what is the time impact of this? So one particular test class over here, this one took 3.5 minutes to run. So when we're taking a look at those 296 retries, it's not just the compute power, it's not just, I have a flaky test. It's that it actually took 17 hours of build time to run this item. And if someone had gone ahead and fixed it in the first place, you would get all of this time back. That 3.5 minutes every time this is running, if you're going to be retrying it up to 3 times, that adds up pretty quickly. So we do know that detection, unfortunately, is not the same as solving the problem. So what can we do about it from here? What we do over at Netflix is we want to make sure we surface this information to project owners in a friendly way. So what we have done is over in our build output, we have a hook at the very end that says, go check out your flaky tests over here with a link to the Devvelocity UI drilled down for their particular project. We also want to be surfacing this in other areas, other UIs where people can go check on their project status, check on the health of their application, and whenever they have time and resources available, they can go and fix these flaky tests. So all of this is going to be contingent on a change in culture where it's not just retrying the build so you can continue and go forth, but we really want people to address these flaky tests because it is impacting the developers themselves, and it's going to be impacting the downstream systems that depend on them, that want to have this change go out, that want to have confidence in the product that's being built. Another aspect or thing that we can do is quarantine these tests. So we're not doing this currently, but we've definitely thought about it and had asks from various teams where if something is marked as flaky, can it be quarantined and just taken out of the system until someone goes ahead and fixes it, makes it not flaky, and then reintroduce it once more. So that's also another option. So our goal overall is that one day we will have many, many days without flaky tests. Another item that we use is Devvelocity's predictive test selection. So let's take a look at what this is. The predictive test selection selects tests that are most relevant to your code change, providing this faster feedback. There was a 2018 paper by Meta. It's a good one to read about it. And specifically, how does this work with Devvelocity? So the predictive model takes a look at the code changes and test outcomes from your build scan data. We want to make sure that we're sending lots of build scan data over into Gradle Enterprise to get good results and good information for the predictive test selection to be able to figure out what are the things that should be run. So for example, it's not going to attempt to make predictions for test tasks or goals where there's fewer than 14 days worth of activity or code on there. Tests will also always be chosen if they are recently new, recently changed, recently failed, or if they are known to be flaky. So one of the things that is important to note on here is that we are trading this build time for test comprehensiveness. So we're doing this in areas where we know that these inputs have changed, this code has changed, and we want to get this faster feedback as quickly as possible so that people can keep working on the area that they would like to work on. So we're going to come back to that in a little bit. So let's take a look at what our simulations said we were likely to achieve before we rolled this out. So this was our monthly predictive test selection simulations for local and CI builds. We have local at the top, CI here over at the bottom, and we're able to see that there was an expected savings potential of 33 days, 8 hours in local, and 73 days, 5 hours over in the CI environment. So this was very nice to be able to see, and this ends up coming to about 30,684 potential hour savings in a year. So what I do want to call out over here is there's not a direct measurement between the number of hours saved and a dollar amount. There's not a direct measure between these hours saved and hours that people are directly going to be working on other things in the code base. But what this is going to let you know is that there is going to be a lot of savings inside of here so that people can get back to the task at hand. They can stay in that state of flow. They can know that the changes they're making, they can get those results quickly. They can run their builds locally, run them often, and not need to wait and just wonder, is my change going to be okay? Do I need to push it up to CI and then wait for a while? You're going to be getting this faster feedback, and that is worth quite a lot. So what we did is we rolled it out to all compatible projects, and we did this in a lovely way. Okay, how did we roll it out? So we ended up rolling it out to compatible projects with just taking a small amount of beta testers at first. We then had about 10% of our applications and our projects and repositories, rolled it out a little bit more there, and then kept this incremental rollout. So what this helped us to do was to figure out, was it working the way we expected? Is it configured the way that's going to make sense for people? What is the messaging that we want to provide? What are the questions that people have? And so as we had this beta user group, we were able to find out the information that they wanted to know, and then as we were increasing this rollout, just provide that in town halls, newsletters, that kind of thing. So here was our results in the very first month. We can take a look and see that for test tasks which enabled predictive test selection, there were 87% of these that is going well. Oh, come back. Man. We were also able to see that there is 88% of total serial time saved right over here. So this is wonderful results that match up really, really nicely to the simulations that we were seeing. And this made us very, very pleased. We've definitely got a bunch of feedback from developers in the area that say this is making them feel more effective. It's making them help to get that feedback faster, which is exactly what we were looking for. However, not everything went entirely as planned. So the learnings that I do want to share is that while predictive test selection really helps you to get this fast feedback, we are, in fact, trading test comprehensiveness for speed. So there were times where people expected that their build is green, so everything is great. Then things get merged back into the main line, and they see that something went red. We were seeing that this was most commonly happening with missing inputs and outputs inside of test configurations. Let's say someone was depending on a static file that wasn't marked as important to the test. Well, if that file changed, those tests might not have been selected. So we're able to go and chat with those projects, make sure we help with the task input and output annotations, and that is all set up correctly over there. We also saw that some of our tests were depending on different kind of OS level infrastructure, things that weren't being modeled or captured by another kind of task input over there. So that was a little bit tricky to explain to people what was going on over here, but what we did end up doing is making sure that we are using predictive test selection when all the builds are running locally, whenever you have a branch, whenever you have a PR build. And we're able to tell everyone else in our environment that every time you're publishing, every time that you're going to send an artifact to an environment, be it test, prod, wherever, we're going to run your entire suite of tests. So specifically, the predictive test selection is what we're running to get this faster feedback so that you can know what is happening in your code base. But we're still going to have a very comprehensive time running every single one of your tests when it's important, when you need to have that contractual obligation. Another thing that was interesting over here is we learned that a lot more folks are using code coverage tooling than we had expected. So when you're running predictive test selection, let's say only 20% of your tests were selected, your code coverage tools become very angry that there's only 20% code coverage, or 20% of what there was before. So there was an impact over there, and we're still talking with folks to see, would you rather turn off code coverage when we're running predictive test selection, or what kinds of things would make this a nice experience for you? Another thing that we use is DevVelocity's test distribution for remote test execution. So what is remote test execution? This is where you're going to take your existing test suites and distribute them across to remote agents in order to run faster. It's going to take all the exact same tests that you have here, just send them away to run on different kinds of machines. These tests and their supporting files, the class files, the jar files, they're transferred to each agent, they're executed right over there, and their logging and results are streamed back in real time. So why did we want to invest on this area? Why did we want to do this? Here's a nice chart that summarizes what we were seeing the last few years at Netflix in our build time and where this time was being spent. We saw that 88% of our time is being spent during tests. So there's definitely a lot of things that we could be doing to make everyone's builds go faster so they can run the whole thing and get this faster feedback. We want to make sure also that we have a consistent experience between CI and local. With having these test agents running everything, you're not going to have that problem of, is this set up well for my Mac? Is it going to work the same way over in CI? Instead, we have the same agents being used for your local builds, for your CI builds. This is also going to have better compute resource usage. So we know that as we have our CI agents, there is a cost to this cloud capacity, and we're able to have agents set up for this test distribution, dedicated agent pool over here that's already configured and well suited to running tests, while the other CI agents themselves can just start the process and collect the results. So overall, this is going to be resulting in faster feedback for all the developers. It's going to be resulting in the ability to run your tests locally, run them more often, and keep a nice, tight developer inner loop that people are going over and over inside of here. So let's take a look at what life looked like with before remote test execution. So this is one of our projects from my team. It's called Netflix Gradle Lint. So what had happened over here is this is a regular day. We were running our build, and we got to wait for an hour, for over an hour, to find out that actually there was one failed test task inside of there. So that didn't feel great. At this point, we get to go in, figure out what was the thing that failed, fix it, and then run our tests again. What was really wonderful, however, is that after remote test execution, we had that fix in place. At this point, our entire build, running every single exact same test, took less than 5 minutes. So with all of this, it gave us massive amounts of parallelization so that we could just spawn off our tests. We weren't resource constrained by running on our local machine or running on our CI machine any longer. We had lots of tests that required high amounts of memory, and previously we could only run 3 or 4 of them at a time, let's say. With using the remote test execution, we could just run them all over at once. So this parallelization, this stability between environments is a massive win. So I do want to call out that there are some potential limitations and that you might run into over at your company. So what we saw is we end up having a lot of tests that do require network or security access. So these are things where, as I'm running my test, the test has that knowledge that I am Aubrey, this is my machine. I have access to talk to some sort of applications over in the test environment. I'm allowed to talk to AWS resources. We have similar knowledge about the CI agents themselves that's baked in there. But for our test distribution agents, one of the things that we're working on is getting this story closed to be able to propagate our identity and access. That way, these test distribution agent pools are built in with the knowledge that this is my application. This application has the ability to talk to these resources. So that's one of the things that we're working on. There might also be a limitation around different environment debugging. Currently, what we do whenever you're debugging a test, we fall back to local environment and as opposed to a remote test executor. So what you might see is that if you're debugging something that specifically you want to repeat what's happening in CI, you might need to just change your configuration a little bit. Finally, there is a limitation potentially around network traffic and slow connections. So as people are working not necessarily over at the office, working with a slow connection, working at a coffee shop, these kinds of things, as you're packaging up all of these class files and jar files and sending them over the network, you might notice that your tests are taking a little bit longer, but that's due to your network latency. So at that point, it might be useful to just run these locally and then wait until you have a great network connection to be able to distribute them after the fact. So at Netflix, we currently have this as a beta offering. So we have 14.8 thousand out of 233,000 builds where this is currently turned on, so 6.4% of them, and also enabled for 16% of our repositories. And we are working to fill our gaps. Right now, the reason that it's here as a beta offering is just because we have a large amount of tests and projects that do require that network and access management. So, what are some of the learnings that we've had along the way? Because boy, did we have some. So some of these are going to be technological solutions. As we go through here, we were able to see that with these items that I was talking about, we enabled CI job parallel executors. So one of the things that's actually been really cool, as people come into our engineering help channel, they're sometimes asking, my build failed due to out-of-memory errors. What can I do about this? And then there's multiple teams, not just our own, who are now saying, why don't you try test distribution? Because that way, your particular machine is not going to be resource constrained. You're not going to be running your build right here, as well as running all your tests and trying to have parallelization. Just send them off to different agents. So this was a big win for us. We're also increasing our testing against real data stores and AWS cloud resources because we're able to just run our tests more frequently, have more tests inside of there. We have a reduction of the CI agent failures due to misconfigured test suites, and we're able to reduce our CI compute resource usage by also having these test distribution agents. We also have various kinds of social solutions that we implemented. Oops. So one of them that I had touched on is that the very first example, we were able to apply this solution to one project at a time. We can also apply these to all projects over at once. We can do a staggered rollout. And whatever strategy you're using here, you want to make sure you're using good judgment to find out, is this something that should be very, very targeted? Is it applicable to a beta group at first? Is it something that we can roll out to everyone all at once? So what we do over at Netflix when we want to roll things out to all of our projects is we have a Bootstrap plugin, which all of our projects apply. And then as soon as we want to release a configuration change or roll something out that we think will be really useful for everybody all at once, we can do so. Or we can have a staggered rollout and choose, I want to roll this out to projects that start with the letter A, for example. So when we rolled out things like test retries and flaky test detection, we saw that this is something that we want to have all of our projects using. We tried it out with a beta group of people and then rolled it out everywhere all at once. As opposed to that one, things like predictive test selection, we did a little bit more of a slower rollout so we could learn more things along the way, learn how people were feeling and what questions they would have. So another thing to keep in mind is we want to make this simple. Be clear on what is changing and when it is changing and what to expect over here. So over-communicating the ways that folks can find this useful information. We want to make sure that we're sharing it in various kinds of posts, in newsletters, in forums, so that people can see what are the things that are going to be different over here. We also want to prevent migration fatigue. We want to enable low-effort opt-in or opt-outs over here. So every time you have a change that people need to manually put in there, or you're asking someone to make a change, there's a cognitive overload of, what is this really going to be doing for me? Do I want this? Do I have the time to look at this right now? But instead, if there's things that you can put into place with things like a Bootstrap plugin, you can make these choices for folks, let them know what is changing, and let them know the benefits of what is going on over here. So another area is that we want to make sure that we have understandability, great documentation, and great tracking. For this, we want to provide actionable error messages that point to the further documentation. So you get this particular error, it says, go check it out over here. This is where you'll find out tons more information. We want to provide actionable pull requests with informative messages that are tracked in some sort of campaign. So we say, we have provided this adjustment for you. Here's more information about it. Here's why we are doing it. Here's the benefits that it's going to give you. And we also want to have a great way to spread awareness of the new features that save people time and energy. So there's things like newsletters and town halls, feature reviews. These are all going to be great ways to get this information out there. Another one is being able to beta test each of these features with your team and close partners. So we definitely talked about this one over today, but finding these customers who are going to benefit the most and work with them so that they can help lead this effort. This is something that was very great for us, especially around things like test distribution, where we found what are some of the largest projects that have tons of tests that are resource constrained. Pick them out and say, would you like to try this out with us? And they were delighted. So hearing what goes well, what didn't go well with them, where it's very impactful, was wonderful for us. It gave us tons of good information, and then as they are enjoying the process, they are also spreading awareness, so it's not just our team who is talking about this. We also want to communicate expected outcomes and risks, and finally, measure before and after this feature has been introduced. So we can have those cool slides like up there of, here's what it looked like before, and the difference going from an hour to 5 minutes, for example. So overall, just requesting feedback is super important. We want to make sure that as we are rolling things out, we're going to hear from people what they like, what they're confused about. We want for people to feel confident in their own test suites and feel confident in the changes that we're making, that we're helping them out, helping them to feel more effective. So, are you with me? This brings us to the last thoughts over here. So scale doesn't matter. For each of these examples, these are things that you can apply to one project. You can apply to the 3,400 active repositories all at once. All of them are applicable to each of these cases. We also want to treat the testing process well. Testing doesn't have to be slow, doesn't have to be painful. It can be a nice, fun time that is going nice and quickly. We want to invest on the testing experience so people can have really wonderful payoffs while they're writing these great tests. We want to enable these fast testing cycles, keeping the developer loop running very, very quickly. And treat your test suites like production code. Make sure that they're also evolving the way that your production code is. So as a one final recap, how do we go about doing this? So we enabled things like flaky test detection and test retries. We enabled Develocity's predictive test selection, as well as the test distribution. We made sure that we're attacking slowness. You see this cute little sloth over here? Attacking the slowness in various projects, making sure that we have things configured as they should be, and working with our beta customers, working with customers in an incremental rollout, and getting that feedback over here. And overall, we just want to make sure that this developer inner loop is top of mind. We're making sure that people can go through here, they can commit, run their builds, run their tests, do it all locally, and get that feedback really fast so that they feel in that happy flow state, they feel productive, and they can get things done. So, any questions? Question over here. I see there's microphones up front. I think a microphone is headed towards you.
Great presentation. I mean,
Thank you.
It was amazing listening to you. Cool. I do have a question. I think you might have mentioned this, but I might have missed it. The test retries, are they automated, or how are you doing those?
Yes, so the test retries, we have it configured to try up to 3 times. So that's something that It is automated. It's just going to go through that process automatically once we turned it on. So the only thing that we needed to configure is who we're rolling this out to, so those specific projects, in this case, all of them, and also how many times we'd like to have those retries. I'm sorry, what's that?
Does that strain any bandwidth, or it's okay? Because I'm thinking for big projects such as yours, I mean, that might be pretty costly.
We have found that it's a really worthwhile trade-off of the extra time or extra compute capacity that's in there. The alternative to retrying these tests is that your entire build is going to go red. At that point, the developer is probably, like we heard earlier, going to just retry the build anyways. As well, they're going to have to spend that time investigating what was this test failure? Is it related to my code change? Is it something I need to take a look at? Is some environment down? Are my dependencies having a problem? And just, it causes a big flurry of activity. So what we found is having those test retries is really, really valuable so that people can get the work that they're doing across the line and then have that knowledge that I really should come back to this particular amount of tech debt and fix this flaky test. Yeah, you're very welcome. It was a great question. Oh, we have another question over here.
How do you think about, what are your thoughts around quarantining tests, right? So I understand you have not rolled this out, it's under discussion, but what are the different kind of things you're wondering about how to do this and the pros and cons?
Yeah, that's a great one. So for quarantining tests, I think that it's going to have a similar, when I take a look at things like the flaky test detection dashboard, the area that we haven't connected the dots yet over at Netflix is how to get people, one, to see this result and then take action. What is this next step on here? So with quarantining the tests, I think I still have that same question of what is the next step that we want for people to take? I think it's really useful to be able to have this information, potentially to be able to quarantine it, to just do something so that you're not having a test give a bad signal and lower your confidence that's going on over here. But the answer that I don't know and we're trying to figure out is how do we make sure that this quarantine test doesn't just get ejected in no man's land forever? How do we make sure that something that's marked as flaky does get addressed? How do we make sure that it's going to get that insight over there? So currently I feel it's similar to marking a test as ignored inside of the code base. There might be different ways where there's different tracking systems, but that's not something that we currently have in place. Yeah. Ooh, another question.
Hello, thanks for the talk. I have a question. I'm curious what the sentiment of the teams was when you first approached them. Like, were they like, oh my God, I'm so happy you're here and we have these big problems, we're not trying to solve them? Or was it more, maybe like a cultural problem of, hey, you have 3 flaky tests. Did you know that? Like, are you tracking this? What was that like?
Yeah, so our team has been around for many years over at Netflix. And so they're familiar with our faces and the things that we roll out and being, like hearing from our newsletters, going to our town halls, these kinds of items. So when they heard about some of these features and specifically around test retries and flaky test detection, one, they were super excited that they had many fewer builds that were just going red for strange reasons. We saw a reduction in our support Slack channel where people would say, hey, my test failed, can you help me figure it out? I have no idea what went wrong. And we would say, what do you know? We also have no idea what went wrong. This is your test code base. So it was really helpful in that particular area. I think that there was a little bit of a disconnect from our perspective about this is something that we have provided to folks where people initially started thinking, oh wow, my tests are just much better than they were last week. So we want to make sure that we're sharing this dashboard and sharing this sense of actionability and having that cultural change inside of there. And so that's definitely something that we're working on to help close those gaps and say, like, now that we have provided you this information, how would you and your team like to address this tech debt, which is allocated over here? So we're still working on figuring out, like, how do we get this flaky test to a smaller size? Another question over here.
Yeah, it's a related question because I definitely understand your reasoning behind introducing the retries and detecting flaky tests. But at the same time, you can say that you're kind of treating the symptom and not the root cause. And it also removes some of the incentives to fix those flaky tests if they normally succeed within 3 tries. So I'm just wondering, did you guys have that discussion in-house, whether this is a good idea versus a bad idea? Or was it just like, we just got to fix this because it's such a big, slow blocker for most of our teams?
Yeah, that's a wonderful question. So definitely figuring out what is the root issue is something that we think about a lot. We think about this in test retries. We think about it in a bunch of other ways where we want to get that feedback and that confidence that what you're deploying is actually going to be working the way that you're expecting. So we had some of these conversations that you're talking about, and we wondered, what are we trading off here from having a test retry versus just failing the build? And what we did see is that people were spending much more time triaging things that were just due to network failures or strange interactions or kind of one-offs. And people felt really unhappy about it. We had lots of sentiment surveys. And they say, oh, why is our infrastructure having these problems? And we say, it's normally not. It just happened to that one day. And being able to surface that there is some sort of infrastructure potential issue inside of this test, that people should take a look at it when they have some downtime, we found to be a much more valuable approach so that people still are getting the benefit of having these in place. We don't need to go on a roadshow and say, we noticed that your tests are flaky, we have turned them all off. Because I don't think we'd be very popular at that particular point. But just being able to surface that this is something that they should be investing in so that the team can feel better about the product that they're shipping, this is a great way to treat that process so they can still get their work done, they can get the things out that they need to do, and they still have that test that does give them confidence as long as it does eventually go through. So we found that, yes, on one hand, it is treating the symptom, rather than the underlying cause, but it's still definitely worthwhile. It helps people be more productive, and they can go and fix it on their own downtime. So over at Netflix, we have a big culture of freedom and responsibility, and this does play out in that particular way, where we want to make sure that people can get the things across the line that they really need to, and we trust that they're going to be able to fix the items that they know are holding themselves back when they have that time. Yeah. How am I doing on time, or do we have...
If there's no more questions, then everyone can go to lunch and try to eat quickly, come back here at 1 p.m.
Okay.
Check out the beautiful patio.
dawn. Falling, be gone. I will stand as I've done again. The reason for no more overnight. The minute I was thinking to hold you back, the moment I was wishing it's overnight. The minute I was thinking to hold you back, the moment I was wishing it's overnight. The minute I was thinking to hold you back, the moment I was wishing it's overnight. The minute I was thinking to hold you back, the moment I was wishing it's overnight. Slow down, never. I know now, I know better. I need it more than ever. Go back under, hope that I fall on the track. It's all I've said and done. Overnight. The minute I was thinking to hold you back, the moment I was wishing it's overnight. The minute I was thinking to hold you back, the moment I was wishing it's overnight. The minute I was thinking to hold you back, the moment I was wishing it's overnight. The minute I was thinking to hold you back, the moment I was wishing it's overnight. It's overnight. The minute I was thinking to hold you back, the moment I was wishing. The minute I was thinking to hold you back, the moment I was wishing it's overnight.
overdraft is, etc., doesn't do it. There's got to be some contact with the real world. That's where issues around doing some work, learning to save, matching somebody's college savings account, but actually just in contact with the real world is hugely important. The balance, I think, is to give people enough of just the knowledge, the basic knowledge, so that when you then do hit the labor market, you hit the financial institutions, you get back. You've got some basic knowledge, but I don't think anything is really practical experience. So leaning financial institutions to kind of practical knowledge.
In what way? How do you
We start out thinking about what do they make, what's their pay, secondarily what kind of cash flow, then what's healthcare, then there's a 401k, then there's a share repurchase plan, then there's Live Better You where we pay for education. So there's a whole system of things that our associates frequently don't even know about. They're coming to work, doing their job, they're going hard, for whatever reason, their communication not working. But at the end of the day, what we want is to help 75% of our so it's not where you start, it's where you finish. You need to save some money, you need to understand what interest rates are, savings, you need to understand what the goals are, you need to so we want to invest all this money in ourselves, but we want to do well, have a retirement, something we're looking forward to. So this is really important to us. And what happened, you and I got engaged, what happened with a lot of these conferences, we said, yeah, we have a program where we teach financial education and wellness, but it's just one thing that we do out of so many. We're not as effective. So we have dialed it up. We have now developed a speaker who are accountable for making sure that not only do you have the right tools, but you also are
Out of love, pass down bad habits of generation to generation. But it's what we don't know that we don't know that's killing us. There's not a welfare mother in this country that doesn't want her child to be successful, intelligent, hardworking, taxpaying, and for no other reason than to feel proud of them. But you can't give what you don't have in a blind town, a one-eyed man's king. If you don't know better, you cannot do better.
I've been where you've been. I was homeless for 6 months. My credit score was in the 500s. Now I've got an American Express black card, and I roll like 10 apes. And you can live this dream. My mother owns 7 homes. I own 700. I own 700 homes, rental homes. You can do this, but you've got to acknowledge you have a problem. 70% of Americans live in paycheck to paycheck. Most folks watching this have too much money at the end of their month. Okay, let's acknowledge that. Okay, the saint is a sinner that got up. Call my people. They're all certified with 33 federal government credentials. HUD certified, SBA certified, all that. And let's have a conversation.
The beat goes on.
I know a lot about being broke because I was broke. I know a lot about being poor in spirit because I was poor in spirit. So when I'm talking to people, I'm not talking to them. I'm really testifying from them. So fast forward, really too much of my own press.
let's have a conversation.
Still moving strong, and I love it. The beat goes on, 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 and the beat goes on.
Yeah, I do think it's
Just like my love, everlasting. Oh, and the beat goes on. Still moving strong. And the beat goes on. Just like my love, everlasting. Oh, and the beat goes on. Still moving strong, and I love it. And the beat goes on. Just like my love,
You've got some basic knowledge, but I don't think anything can really replace practical experience.
Time flies
So,
by when the night is
leaning
young.
financial
Daylight shines on an undisclosed location. Location.
Financial literacy, does that relate to
Bloodshot
Walmart
eyes looking
in this
for the
business?
sun.
In what
Paradise
way?
delivered and we
What's
called it
the
a vacation.
We start out thinking about what do they make, what's their pay. Secondarily, what kind of cash flow is coming in. Then what's healthcare? Then there's a 401k. Then there's a share repurchase. Then there's Live Better You.
Over the hills and far away.
So there's a whole system of things that are associated with it. We don't know about. They're coming to work, doing their job, they're telling us
I know we've got to get away. Someplace where no one knows our name. We'll
and at the
find
end of the day,
something
number one,
new.
it's a great opportunity.
Just take me anywhere. Take me
So it's not where you start, it's
anywhere.
where you finish.
Anywhere away with you.
Save some money, you need to
Just
understand
take
what
me anywhere. Take me anywhere.
tools are. You need to know the tools.
Anywhere
And
away.
so if we want to invest all this money in ourselves, but we want to do well, have a retirement that is so this is really important to us. What happened when you and I got engaged is what happened after the lobby started. We said, yeah, we have a program that we teach financial education and wellness, but it's just one thing that they do out of
Truth
so many,
comes out
and we're
when we're
not
backing down.
effective.
Looking for connection in the
We
crowd
have
of
dialed it
empty
up.
faces.
You and I started spending time
Empty
together. Now you've got all these
faces.
leaders that are accountable
Think you're
for
still the only
making
thing
sure
I'm
that
craving
not only do
now.
you have the
The
right
good and the bad in me in,
but
'cause
you
I
also
can
are
take it.
getting more people.
I can take it.
Out of love, we pass down bad habits from generation to generation. But it's what we don't know that we don't know. It's killing us. There's not a welfare mother in this country that doesn't want her child to be successful, intelligent, hardworking, and tax-paying, if for no other reason than for travel. But you can't give what you don't have, and a blind town, a wise man's king. If you don't know better, you cannot do better. I've been where you did. I was homeless. My credit score wasn't fine. I've got in a black car and I roll like 10 acres. And you can live this. My mother owns 7 homes. I own 700. I own 700 homes, rental homes. You can do this, but you've got to acknowledge you have 70% of Americans live with paycheck to paycheck. Most folks watching this have too much month at the end of their month. Okay, let's acknowledge that. Okay, the saint is a sinner that got up. Call my people. They're all certified with 33 federal government credentials. HUD certified, SBA certified, all that. And let's have a conversation.
Take me anywhere. Oh, anywhere. Anywhere away with you. Take me over the hills and far away. A million miles from LA. Just anywhere away. Anywhere. I know we've got to get away. Someplace where no one knows our name. We'll find stars. Oh, we'll find stars. Just take me anywhere. Take me anywhere. Anywhere away. Anywhere. Just take me anywhere. Take me anywhere. Take me anywhere. Anywhere away. Anywhere.
The dangerous person in the world is a person with no hope. That's why we're named.
Man, it's a hot water, like 7 inches forget about it. But I'll tell you one thing. If you would leave it be a crying shame. In every breath and every word, I hear your name calling me out. Well, from the bio, you hear my rhythm on your radio, and you feel the turning of the world, so soft and slow, turning you round and round. And if you said this life ain't good enough, I'll give my world to lift you up. I could change my life to better suit your mood, because you're so smooth. And it's just like the ocean under the moon. It's the same as the emotion that I get from you. You got the kind of loving that can be so smooth. Yeah. Give me your heart, make it real, or else forget about it. It's just like the ocean under the moon. It's the same as the emotion that I get from you. You got the kind of loving that can be so smooth. Yeah. Give me your heart, make it real, or else forget about it. How can we make amends when we said all we said? I call and you don't pick up. How can I say instead that I hope it's for the best? I won't and I won't give up. I'm sorry, mother, I know I let you down. I'm sorry for how I up and left this town. How can we push aside all the bad and make it right? Now you got me all choked up. I'm sorry, brother, I know I let you down. I'm sorry for how I up and left this town. Please just free. I'm what you taught me to be. Shouldn't that be enough? It's time that we make amends. Let's forget the things we said. You know we were all just stuck. I'm sorry, Mother, I know I let you down. I'm sorry, Father, I didn't stick around. Please just listen, cause I don't ask for much. I am my own man, I make my own luck. Please just listen, cause I don't ask for much. Just like my old man, I make my own luck. And some birds are meant to be caged, and some just won't see the light of day. Please forgive me, I can't remember. Please forgive me, no one is calling. Please forgive me, I can't believe it. No. Gonna pick myself up so I don't let December Can't you see? You're my delight. Lady, I just feel like I won't get you out of my mind. I feel love for the first time, and I know that it's true. I can tell by the look in your eye. Give me tonight, 'cause my feeling is just so right. Lady, I just feel like I feel love for the first time. Lady, hear me tonight. Can't you see? You're my delight. Lady, I just feel like I won't get you out of my mind. Lady, hear me tonight, 'cause my feeling is just so
Hey, brother, there's an endless road to rediscover. Hey, sister, know the water's sweet, but blood is thicker. Oh, if the sky comes falling down for you, there's nothing in this world I wouldn't do. Hey, brother, do you still believe in one another? Hey, sister, do you still believe in love? I wonder. Oh, if the sky comes falling down for you, there's nothing in this world I wouldn't do. What if I'm far from home? Oh, brother, I will hear you call. What if I lose it all? Oh, sister, I will help you out. Oh, if the sky comes falling down for you, there's nothing in this world I wouldn't do.
gangs, clubs, and nations, causing grief in human relations. It's a turf war on a global scale. I'd rather hear both sides of the tale. See, it's not about races, just places, faces. Where your blood comes from is where your space is. I've seen the bright get duller. I'm not gonna spend my life being a color. You agree with me?
The session will begin in 3 minutes. The session will begin in 3 minutes.
it's not the same as it was in this world. It's just us. You know it's not the same as it was. As it was. As it was. You know it's not the same. Answer the phone. Harry, you're no good alone. Why are you sitting at home on the floor? What kind of pills are you on? Ringing the bell, and nobody's coming to help. Your daddy lives by himself. He just wants to know that you're well. Oh, in this world, it's just us. You know it's not the same as it was in this world. It's just us. You know it's not the same as it was. As it was. As it was. You know it's not the same. Go home, get headlines, feed internet. I don't wanna talk about the way that it was. Leave America, 2 kids follow her. I don't wanna talk about us doing it first. As it was. You know it's not the same as it was. As it was. As it was. One more time. One more time. One more time. We're gonna celebrate. Oh yeah, alright. Don't stop the dancing. One more time. We're gonna celebrate. Oh yeah, alright. Don't stop the dancing. One more time. We're gonna celebrate. Oh yeah, alright. Don't stop the dancing. One more time. We're gonna celebrate. Oh yeah. One more time. One more time. We're gonna celebrate. Oh yeah, alright. Don't stop the dancing. One more time. We're gonna celebrate. Oh yeah, don't stop the dancing. One more time. You know I'm just feeling celebration tonight. Celebrate. Don't wait too late. No, we don't stop. You can't stop. We're gonna celebrate. One more time. One more time. One more time. A celebration. You know tonight, hey, just feeling, music's got me feeling the need, yeah, come on, alright, we're gonna celebrate one more time, celebrate and dance so free, music's got me feeling so free, celebrate and dance so free. One more time. Music's got me feeling so free. We're gonna celebrate, celebrate and dance.
We'll get started, everyone.
One more time.
I was just told, I don't have an earpiece in, but I did go back to the control room and they said some exciting news. On Livestream, we just passed 30,000 people watching. I'm just kidding, nowhere close to that. We're not that important yet. But there are a few people here. Yeah. The next presenter, we've all messed this up before, and I'm really glad that he's allowed me by switching which position that I don't have to worry if it's GitHub, GitLab, because Lee is one of the original Hula people, because he dropped the HU for the LA. And he was trying to get me to do the hula up here, but I said, no, not today, Lee. So with that, introducing the global field CTO for GitLab, Lee Faus. Thanks so much, Lee.
All right, so I have the pleasure working at GitLab of getting to interview hundreds of VPs of engineering, VPs of operations, CTOs, CIOs, and one of the hottest topics that we hear today, and it's great to, Aubrey's talk was awesome, so much of the stuff that we're hearing is all coming down to data. And without being able to have the data at our fingertips, it's really difficult for us to figure out in the business where we go to optimize. And without optimization, what happens is we create toil. And that toil is something that every company that I talk to is trying to remove, whether that's automation, Gen AI, it's in-browser code environments. Anything that they can do, they're just sort of grasping at straws. So this talk goes through, and I'm going to talk a little bit about how automation and flow metrics, how those two things can be combined, and how we think about that for how we treat change inside of our organizations. So this is my fun picture. So I tell my wife this is me, this is my Tinder profile. So this was a lot of fun. I got all caught up in the Gen AI stuff with Midjourney, and I sat there. Amado and I were actually here for another event, and they did headshots, and I did not like any of my headshots. So I gave it to Midjourney, and I said, turn him into a handsome-looking 40-year-old who looks like he's been to the gym, who's just came out of the sun, and the next thing I know, that's what I was like, that's perfect, that's me. So today, what I'm going to do is I want to talk about simplifying the software supply chain. A lot of the things that we talk about today have really been focused strictly in on the developer. And when I talk to VPs of engineering and CTOs, some of their biggest concerns are the adjacents. What about the product manager? What about the project manager? What about the platform engineer? What about the SRE? What about the security team? How do I get them involved in this process? It's great that I get all this great data, but how do I get them involved to collaborate better? And we're going to talk about the events that come out throughout that entire software supply chain and what they actually mean and how we can use them to better affect change in our organization. And then how events and tasks are related. So we'll talk a little bit about how GitLab is thinking beyond just CI/CD and what that means to our customers. I'm going to talk about measuring tasks, and then finally, we're going to talk about establishing actionable tasks. So this is crazy to me. I created this slide 20 years ago. So there was a guy that I worked with back in 2001. I worked for a small startup. It was called TogetherSoft. They competed with Rational, so Rational Rose, ClearCase, ClearQuest, all those tools. And there was a guy who worked at Rational. His name was Jack Greenfield. And he and I were at a conference together, and he started talking about software factories. I'm going, yes, software factories, more. Let's talk more about software factories. And it got all of this bad rap that people are like, oh, you're trying to get rid of developers. You want to try to bring in robots to write all the code. I'm going, no, no. We want to build consistency, reuse. We want all these things to happen. So when I created this slide, I just talked about the things on the left, and we talk about source code management, issues, change management, automation, all the way to the point that we create an artifact. And when you actually think about this, this is just it doesn't have to be software. We could remove software at the beginning of that, and that's any factory. Think about any factory that you go to. The goal is to create an artifact. And then on the right-hand side, we need to provision, configure, deploy. We have portfolio management. We have observability. All of those things are software logistics. So how do I get my artifact into wherever it needs to go? Same thing. How do I get the pallet of strawberries, how do I get them to the grocery store? There's a set of logistics that happens. And then a lot of things, do you ever sit there and walk through, you know, Whole Foods, Kroger, wherever you go to the grocery store, you sit there and you go, man, you know what? How'd these strawberries get here? They look really good. Nobody thinks about that. We don't think about the person who was in the back, who came in at midnight, who restocked the shelves, who took the stuff off of the truck when it came in the day before, and that truck that drove all across the country, and you know, the person who actually loaded the truck. We don't think about those things. We just are happy at the end of the day that we got strawberries that we can go buy. And it's the same thing here. On the software logistics side, we want to get to a point that we're just happy that we just deploy it. It's not one of those things that we want to have to think about. Did I provision the VMs properly? Were they the right size? Did we make sure that SE Linux is configured the proper way and we don't have any security holes? And which application ID do I need to assign this to? And did it get deployed to the right landing zone? We don't want to have to think, as a developer, we don't want to think about any of that. We just want to know that the artifact got deployed and we're good. So then up at the top, when we combine these two things, it's a software supply chain. And again, I can take software off of the front of that, and this is what we get. Cookies. So one of the things that I find amazing, and maybe I am the only one. Now, I am a huge Oreo fan. Okay? Okay, so since I got other Oreo fans, have you ever had a package of Oreos where you had Oreos that were not identical? When you open up the package and you go through, did you ever run through and go, oh my gosh, I've got one that has peanut butter filling instead of white filling? So, okay, so maybe you get a special edition. So one of those things is, you know, they have figured out the software supply chain. They've figured out how to make every single cookie identical time and time again. Now, I've been in the software industry for 30 years. And what's crazy to me is in 30 years, I still walk into an organization, they can't figure out how to do this with their software. They still don't know how to build consistency and reuse. You'll get one, maybe two teams, very proficient. These are the people that get paid the most money. They're able, they go through, and then you find out and you're like, how do you do it so fast? Oh yeah, we don't even talk to security anymore, right? So we just deploy when it's ready and we don't care. We'll deal with it afterwards. So here, this is all about packaging the goods. How do I get through consistency, reuse, and I'm packaging the goods? This then takes us to this picture. Now, I had the fortunate opportunity, I worked for a company in Cary, North Carolina called RailInc. Now, most people have heard of AirInc because AirInc is the company that does all the black boxes in the planes, so when they're trying to figure out what happens when there's an accident, they can go back and read it. There's another sister company called RailInc that does the same thing for the railroads. And it was amazing to me when I went in, I'm like, oh, the railroads, this is gonna be easy. And then I started realizing how challenging it is where you have a rail car, and when you lease a rail car, you don't always lease the entire rail car. You can lease portions of the rail car, so you can do a quarter load. And then there's logistics companies that will figure out, oh, I've got 3 other companies along the same line that they each want a quarter load too, so I can put 4 quarter loads to fill it up so I can optimize the distribution from that rail car. Oh, and then it goes into a container, and then that container goes to a truck, and then that truck goes ahead, and then that goods, each quarter load gets unloaded, and it goes into a van, and then that van ends up showing, it's like craziness. And we could track everything down that we knew the GPS coordinates of any single one of those goods around the world. That was shocking to me, how you could do that. So I've got companies today, when we talk about deploying an artifact, they have no idea where it is. I don't know, might be on Azure. Maybe they deployed to GCP. I don't know, we can't find it anymore. Well, maybe they deleted it. No, because we still get an observability from it, so it's running somewhere. So one of the things that we've done that, as we start to think about getting really good at software development, it's so many of the terminology that we use is so similar. So like here, you've got somebody, they've got a manifest, right? Anybody here deploying to Kubernetes? Right? What do we call them? It's a manifest, right? So we're using that manifest to describe what we want in that Kubernetes environment. We're declaring what we want. And when we declare, we know when there's drift because we're going to notice that, hey, we've got 4 extra passengers on the boat that we weren't expecting. The manifest says there's only supposed to be 3 passengers, and we just saw 7 get off. That's a problem, right? Now that I've got a problem, I need to know how to measure that. I need to know what the expectations are. Do I need to contact border control? Like, what do I need to do? Because I had an event that occurred that was outside of the manifest for me to go off and try to figure out what do I need to do next. So at the top of the food chain across the software supply chain, I talk about 3 different areas. I've got process management, developer experience, and change management. And I use this to simplify this down for a lot of my customers, because when I'm talking about GitLab, we talk about doing all of these things in a single platform. And if I'm talking to somebody in the PMO, I'm going to be on the left-hand side. If I'm talking to a VP of engineering, we're talking about the center. And then when I'm talking about security or operations, I'm talking about the right-hand side. The interesting thing is when I get all 3 of them in the room at the same time, right? So we always talk about moving everything from left to right. That's how we start. Everything starts with an issue. I go into Jira, it starts with an issue. And then from an issue, it goes into the backlog. From the backlog, it goes into a sprint. From a sprint, it goes into active development. Then I have an MR or a PR if you're in GitHub world. Then I go from there. Then it goes in. And then the thing that's amazing to me is a developer. As soon as that merge happens, I'm done. Next task. It hasn't gone through finishing testing. It hasn't gone through any sort of load. It hasn't gone to staging. It's not in production. But the developer's already moved on to the next task because that's how they work. A lot of times, even when we're multitasking across multiple different branches, it's really hard for a developer, especially unless it's inside the exact same code base. I have yet to see a developer work across multiple projects, multiple branches, multiple MRs or PRs. They have a tendency to want to finish the task that they've got put in front of them, unfortunately, because the way that we metric them. We bonus our engineers. I mean, I remember back in the early 2000s, who here was an engineering manager that said, we're going to measure you on lines of code? Because that one worked out great. Oh, okay, lines of code was bad. Okay, we'll get better at this. We're going to measure it on the number of bugs you close. That one didn't work out so good either. So when we think about moving this from left to right and we're talking about measuring developers, we have the CI/CD process that does the exact same thing. We talk about a pipeline. Pipelines run from left to right. We start by cloning the repository, we load the right build tools, we go create the artifacts, we go do all of those things, and it's always happening in one direction. And this is where, like, when I talk to Amado and we have conversations sometimes once a month, sometimes once a quarter, but a lot of times we're talking about this, and like for his team, what happens when it goes the other direction? What happens when I find an issue in production? Do I go back and start on the left and just push it right again? Well, that seems very inefficient because that may go into the backlog. And that backlog item may never even get into an active sprint for months. But it's a critical issue that needs to be resolved by the end of the week. So being able to change up this process so we can now think about moving things in another direction. So as we think about going from left to right, we have all these different events. Now, when I was at GitHub, the one thing that I noticed with every customer that I worked with is they had all these different tools, disparate tools inside their tool chain. So they had something for issue management, they had something for security, something for code quality, all these different tools. And when they went through, every different tool that they had emitted different events. And all these different events had different things tied to them. So when I would have anybody here who, how many people here are using, and it doesn't matter to me, if you're using GitHub with Jenkins, how many people here are using GitHub with Jenkins? Nobody's using Jenkins? It's all gone. Finally, we've achieved nirvana. So when we go ahead and we trigger off of a post-receive hook. That's what happens in Git. Git basically says, hey, I'm letting you know that a change has occurred inside the system, and it will notify another system, and that system knows now to go perform some action. And we do that across the entire software supply chain. So if it's from the developer experience to change management, usually there's an event that occurs like a merge. So a branch gets merged, we have a merge event. That merge event then triggers something in ServiceNow. If I'm in Jira, Jira goes ahead and I've got an issue state that changes. That issue state goes ahead and triggers something in the development environment that says, hey, I've got an active correlated event that I now need to be able to monitor. Now, unfortunately, the way that we treat all of these events are all sitting in their own silos. And because they're all sitting in their own silos, there really isn't a way down the middle for us to be able to link events together. Now, we try to do this, and when we do this, there are so many different tools inside of our tool chains that when we try to correlate these events together, sometimes we mess it up. And other times, we get events that get triggered and they don't do anything. They just goes to a dead letter queue. And what do? How do I do a retry? How do I figure out how to fix it? So one of the things that I have found, and I don't know if anybody else has seen this, but in really large organizations, and I'm talking about places that have 5,000, 10,000, 30,000 engineers, DevOps to them has ended up creating silos based on tooling. So they have the Jenkins team, and they have the GitHub team, and they have the GitLab team. Yes, there are a lot of customers that have GitHub and GitLab in their organization. And then they have the ServiceNow team. And they don't interact with the other teams very well. They are focused on optimizing the utilization of their individual product, but when you talk about, hey, how do I get tool A to talk to tool B, they're like, I don't know, you figure it out on your own. Because I'm just focused on how do I optimize my tool. So what we end up doing is we end up having all of these different events across all of these different, and like a lot of our customers will end up tying in observability tooling. So they'll take their Datadog or their Splunk, or they'll take something else and they'll just try to capture all of the events that are happening, and then they try to build dashboards on top of the events and trying to then correlate them together. Now, for those of you that know anything about Git, I used to have this happen at GitHub. I still have it at GitLab. I've got people that are building dashboards off of these events. And these dashboards are snapshots in time. Now, when we create these dashboards, the dashboards are okay. But when we actually want to correlate that to change, it's really hard. I had a customer that they were very proud of their dashboard. This would have taken them 3 years to build their dashboards. And then they went through and they had one metric that I saw, just happened to pull it out. And I said, let's drill into that one. And they go, well, we can't drill into that one. Why can't we drill into it? Well, it's actually the Git commit. Okay, well, let's drill into the Git. Well, we can link to it, to the tool, and then the tool can then show us. And I'm like, so now as an executive, I'm looking at this dashboard, and now you want me to go into GitHub or GitLab and have to go in and try to figure out on my own what's actually going on with that change to figure out why is that number so high. Like, yeah, this is an issue. And the reason why that's an issue is because we have these things called webhooks. Right? So webhooks are the dumpster fire of our tool chain. What happens with webhooks is it's a fire and forget, and when we want to actually use the data that's correlated to an event, that webhook, if it didn't get triggered and go to the next system, I actually have an issue with my data. I have data corruption. I'm now missing an entire thing. Now imagine if that was your SCM tool talking to your CI tool, and your CI tool had 150 steps inside of its pipeline, and it didn't get triggered. The developer's going to come back. We heard this morning, right? So what do? I'm going to go back and I'm going to retry. From what? You're going to go back and retrigger the webhook? Are you just going to restart the pipeline? Because this could actually be your issue. It's great that I restarted the pipeline, but if the webhook sent the wrong data, my build's not going to be running off of the proper change. Oh, and by the way, if I'm running a webhook and I don't know which webhook actually triggered the issue, which one I'm missing, which means I need to know the one that should have happened before and the one that happened after, I may actually rerun a webhook that's actually currently in build. So this, to me, is the biggest issue that I see with every single one of our customers is trying to rely on non-guaranteed delivery for being able to optimize their tool chains from end to end. So if we had a way to be able to, anybody who is trying to do this today, and my sales team will hate if I say this, but if you're going to do this, you really should have an event bus. I've talked to so many customers. I'm like, look, go ahead and install Kafka. Just install Confluent, make it your message bus, and every webhook should go and just create streams across different tools, and then you can go ahead and do whatever you want off of them. At least you can have a better chance of delivery unless Confluent's down. Then that's a whole other issue. Now, when we go ahead and we have these events, most of the time an event maps to a task. So I ask, from this event, I want to go do a task on the other side. And this is the same thing. I have this, my wife, there's an event that happens for my wife, and that means a task for me. So unfortunately, I wish that's the way it was at my household, but unfortunately, it's actually this. One event means multiple tasks. So when we go ahead and we do a one-to-one, it's very easy for us to tie our tools together. When we have one event that maps to multiple tasks, anybody here who has ever built an event system and has to do a scatter-gather, it's really hard. Scatter-gather is hard to do because then you've got to have IDs and things like that. This goes into a whole other issue. In between GitHub and GitLab, I worked for a company that supported the open source Spinnaker project, which I love still. But the issue that we had was anytime we would plug it into an SCM tool or into a CI/CD tool, the webhook that would get triggered, there's no way because Spinnaker could have manual tasks. So if I've got a manual task, when do I ever get my status back? So they would cheat by just sending a 200 back of saying, hey, I'm letting you know I received the event. But then my CD process would happen, and I wouldn't know if it would fail unless I would actually go and log into the tool and try to see if it failed. There's other CD tools that are in the exact same situation, which is where a lot of our customers want to move towards a declarative model, a manifest model, and use things like GitOps. Because now I've got a manifest and I actually know what should be deployed in that environment. Now, doing events and having multiple tasks, again, that fire and forget seems to be the mode of operation. But now what we're starting to see with a lot of the needs for guaranteed uptime and having certain metrics that we want to start measuring our teams off of, we're starting to see this, where we now have tasks that need to be bidirectional. So I've got an event that actually has a corresponding event, and I need to take the payload of that event, and I'm now going to inject additional data based on the response of a task to then feed that along to the next event. So that then creates a whole other set of issues. So the way that I like to talk about this is, now imagine when you go to the bank. So we think about this being very simple transaction, right? You take a check, go to the bank, and you say, hey, I need money, here's my check. And then what happens? They give me cash back. It's a pretty easy exchange. That's that simple event task correlation. But did you ever think what happens on the other end when that teller's actually going ahead and giving you the cash? All of the things that they do on the computer. So they've got to go ahead, validate that it's your bank account, because there's other people I wish I could take their money out of their bank account. But they're going to validate it's my bank account. Then they're going to go ahead and deduct out of my current register. That's going to go ahead and generate a receipt. That's then going to go through their COBOL systems, everything on the back end. There's all of these other systems behind that teller just for me to go ahead and get the $50 that was in that check. And when we go ahead and we think about all these different tasks that go on day to day from a development perspective, we want to get to a point where, imagine if you went to the bank and they said, yeah, that $50 check, would you mind going over and having a seat? It's going to be about 30 minutes for me to go ahead and get through that process. You're probably going to start looking for another bank, because we want that task to be very efficient. We expect to go in, we have an expectation that we're going to get our money and we're going to leave. Now, what's even worse is you go in, they say, oh, we're sorry, our computers are down, I can't get you your money at all. Then that's a whole other issue. So being able to think about all these tasks that happen in a developer's world on a day-to-day basis, so many times there's all these adjacents that we just don't put enough weight on to be able to measure, so we can figure out how can we do this more efficiently. So now if we start to go through and we start to think about our events and our tasks, and we start to measure timelines. So we've got a start-stop for our event, we've got a start-stop for each task, and then we've got a start-stop across the entire orchestration across all of the different items. Now that I've got start-stops for each one of them, I can now measure the time that it takes for each one of those, and I can start to build efficiency metrics. So now if I look at those events, I look at those timelines, again, if we go back into that multiple tool scenario, every single tool has its own data layer, and they're not all relational. Some are stored in document styles, some are stored in timelines, some are stored in binary. I mean, there's all kinds of different things to the way that they get stored on the back end. So if I've got all these tools with all these different data, we end up in the same event situation that we have silos of information. So how can I get all of this data out in a way that actually makes it meaningful? So what we're starting to see with a lot of our customers is across all three of these areas up at the top, CI/CD really fits in underneath developer experience. And then for process management and change management, now we have all these other events that occur throughout the system. So I've got my ticketing system, I've got my Jira, I've got my ServiceNow, I've got all these other things, and I can now collect all those events and I can provide automation around each one of those. Now, if you notice here, the automation is now going to allow me not just to go from left to right, it's also going to allow me to go from right to left. So one of the things that we're already starting to see is when you're using GitLab with our environments and you deploy from that environment, we can monitor the deployment, and let's say I've got a Docker image, that Docker image has a CVE in it. The developer how do I resolve that? Who's responsible for updating the Docker image? So now if I can take that from right to left, I can now make that an issue that now pops up back into hopefully an active sprint, and get it resolved quickly, get the security remediated. Now the developer and the security team are working together. I now need you to update so you can now include the new Docker image that we've now built for you. Those kinds of things are really important for us to be able to figure out how to get this right. And because we're measuring that timeline for every event and every task of both CI/CD and all these automation tasks, I need a single data fabric underneath it. And that single data fabric allows us to be able to have both metrics and analytics around each one of them. So what kinds of things can we get out of this? And this is going to look pretty familiar. Oh, hold on. Let's see. Yeah, let me go back. Hold on. So I don't know, anybody here watch the Netflix Drive to Survive? Right? Nobody? I have to tell you, I am a F1 fan forever now, just from watching Drive to Survive. So I am intrigued by the number of sensors that are on the cars and all the data that's collected and everything. Now, could you imagine if the only thing that they gave Lewis Hamilton was, hey, I'm letting you know the tire pressure in your right tire's low. If that was the only data point that you had, Lewis Hamilton would only be concerned about the tire pressure in the front right tire. That's it. But what we do is we collect all this data across every single sensor, and they're able to correlate that data all in milliseconds to be able to tell the car, I need you to pit. Or as I love here, box, box, box. Box, box, box. So when they come into pit, they know exactly where on the car there's an issue. Imagine being able to do that in your software development process. You're collecting the data and you can say, no, it's right there. It's that line of code. That's what's causing our issue. That's the point that we have to get to. And without having the right data, we can't get to that point. And it's not just one data set. It's not just measuring the front right tire. It's all of the data across everything and being able to correlate those together. So what we see are actionable outcomes that we can get from our different data points across the entire software supply chain. So we talk about crawl, walk, and run with our customers, maturity levels. So if you can't measure these things on the left, and I'm talking about everything, even those COBOL applications that nobody wants to touch, you still need to be able to measure these things on the left. I tell people it's really important, if I'm doing a COBOL application and my deployment frequency has been for the last 6 months, I've been deploying once a month, and all of a sudden we see in August that we deployed 32 times, might want to investigate that, might want to try to figure out what's going on. Why all of a sudden did we need to deploy multiple times? Other things are lead time for change failure rates. All these things are things that we would see in the quote-unquote DORA metrics. So these are items that I push back on development teams, and I tell them, this is for you to measure. These are things that you need to figure out. Then when we start talking about walking needs to move a level up inside the organization. This is where I'm starting to correlate multiple things together. If I've got a microservices architecture, I've got multiple projects, I now need to not only have the eventing backend, I've got multiple databases, that I've got release orchestration, so now I've got to look at things like SLIs, SLAs, SLOs across teams. I've got to look at customer NPS because customer NPS, there might be a certain part of the application that they're not happy with. Also internally. And then one of the things that has really gotten an uptick for us is we talk about cloud cost optimization, but one of the things that is really, I don't know what it is, but a lot of CTOs now want to do cloud cost optimizations for CI/CD. That's really where they're focused right now. And then the teams that we consider that are run are being able to look at their flow time, how much time is a developer, quote unquote, in the groove, team health, what does our turnover rate look like, how happy are the people that they're working, like do they come into work and they only stay for 3 hours and then they decide to go home, like little things like that that can lead to something that maybe you want to monitor. Flow velocity. Now, the one thing that's very interesting is I love people that like ask a question about flow velocity because part of my major was in physics, and when I actually think about velocity, there's all kinds of things that go into velocity that is not what we think about in software. So where's my friction? How fast was I going in the beginning? How long does it take for me to slow down? Like there's a lot of things that talk about velocity that when I equate them to the software process, a lot of very interesting things. Number of vulnerabilities, this has become very important. Like how many people here have projects that have unmanageable backlogs? I still have projects I know have unmanageable backlogs. Now we're having a lot of security teams that they're telling us they have unmanageable vulnerabilities. There's just so many vulnerabilities, and they don't know which ones are false positives. They don't know which ones actually have active code where they could actually hit the vulnerability. That it's really scary that we go in and we start to look at some of the different changes. And these are companies that might be managing your money. They might be optimizing the software in your car. So as you go ahead and you go to hit auto drive, good luck. There might be a vulnerability there. So with that, I want to say, I hope that as you go through and you start to think about all of the different areas about where you've got events, where you've got tasks, how you can think about being able to measure those things and how they impact the overall software supply chain, please don't hesitate to reach out to me. People have actually been very surprised how quickly I respond on LinkedIn. I travel a lot, and there's very little to do on an airplane than to respond to people's LinkedIn messages. So feel free to reach out to me, and I'll open it up and see if anybody has any questions. I scared everybody.
You identified webhooks as like a common issue in the tool chain. Why do you think that this issue with non-guaranteed delivery with webhooks is like such a prevalent problem? And like where exactly is this happening?
So it's the conception that people believe that it has guaranteed delivery. So if I go across and I've got, say, 10 disparate tools in my tool chain, and every single one of those goes to a webhook, there's the expectation that the webhook is going to go and trigger another system to go perform some work, and I'm going to get a response back from that. And so that's how we're going to use to be able to capture the metrics for us to be able to determine, do we have an issue? Like, imagine sending off a webhook to your security provider. And all of a sudden, a lot of times, just like we were talking about with CD, if it's going to run for a very long time, a lot of times that webhook actually returns, because it's a webhook, it just returns a 200 to let you know it was quote unquote sent. But the tool itself has gone off and it's going to take a while for it to run and you never get a response. So now you're looking in your pipeline shows green. It's saying, hey, I got a 200 back, we're all good. But then what happens is the tool itself actually found 16 criticals in your system. So now, again, when you talk about DPE, and I start to look at what does that mean for context switching and cognitive load, and at what point am I just trying to focus in on just trying to fix those security issues versus adding value to the software, to the code base? Those are the things that we start to run into. So we're seeing a lot of the tools today. So we're seeing it with Harness. Harness is doing the same thing with Gitness now and with Drone. GitHub's doing the same thing by now having actions and having their security tools. And you've got GitLab that we've got our platform with everything. We're no longer sending webhooks. We're actually embedding that process where we can guarantee the delivery inside the platform itself. And that's where we're seeing more and more of our competitors. That's where they want to go to. So a lot of the third-party tools that are sitting out there, they're really trying to figure out how can they get themselves into that ecosystem, because they want that guaranteed delivery as well, because that only is going to provide better data to their end users and it shows more value to the end state. So great question.
I have one question about the service level agreement and vulnerability. Like when you deploy third-party product or integrate with your major product, and when there is, let's say, critical incident, then of course service level agreement can go down.
Yep.
But there is a like a major, means critical major and minor. Generally we calculate that way. So when there is a major, how you means come up with the 99.999%, then how you reduce that? How much level you reduce that in that?
Yeah, it's a great question, and it really depends on, like, I've worked with a lot of executive teams, and they want to know what parts they own versus what parts they're consuming from like a third party. And when you start to look at things like SLAs, I have to explain to them that this really comes down to cost. So one company I was consulting for, we went in and their internal e-group wanted 5 nines of uptime. So what we did is we showed them all of the third-party tools that we were relying on and what their SLAs were to us. And then we said for us to get them to that level, these were the things that we would have to negotiate into the contract, which was not in the contract. And when we looked at the cost to that, we could actually go from 99.999%, and just for easy math, let's say that was $1 million. Every time we dropped a 9, we got to remove a 0 from the end. So when we got to the point where everybody agreed that, hey, 99.5 was good enough, we all of a sudden went from $1 million of spend to now being able to accommodate that in $1,000 of spend. And that was shocking how much the e-group thought that, hey, this is just something that we just do. And we're like, no, when you're trying to integrate these tools together, if they don't guarantee that level of SLA and you've got to build a lot of stuff around it to try to keep it away, sometimes it's even better just to say maybe we need a different product. But it's a really good question. When you start to talk about degrading service through that SLA, it needs to be, again, that is an event. You degraded the SLA to your end customers. That degraded timeline that you have then needs to be stored. And I tell people, I hate talking about auditing and compliance, but there's things that we need to do a better job of auditing and compliance internally too. So now you can audit and say, hey, we've got these third-party vendors that are not meeting their SLAs to us. And what do we do to be able to potentially find a competing vendor? What do we do to possibly build this ourselves? And then that goes into the whole build versus buy discussion. But you have to have the data before you can really determine what that is, what the outcomes are that you need to be able to pass that up the chain.
And I have second question about the vulnerability. How many percentage of you devote the means in your budget, or how many percentage? Because every single day we find something new, and it is very difficult to forecast that how many percentage we can forecast, because certain things we can't even assume that, and we come up suddenly. So do you measure forecast every month or every quarter?
So if I understand the question correctly, so when we're talking about vulnerabilities, how much time do I allocate to an engineer for being able to resolve the vulnerabilities?
Engineer as well as cost-wise, because of course that I believe that you have a team of the people who focus particular, two team, basically they are just focused on a vulnerability. One is continuous testing, and one is when anything triggers, then they can able to defense that things.
Yeah. So for me, remediation happens in 3 steps, and I can actually allocate that to different types of developers inside the organization. So when I talk about remediating vulnerabilities, I can take a junior dev and try to determine if it's a false positive. So that's pretty easy for a junior dev to go through and determine that. Then I need somebody who's a little bit more senior to try to figure out if I've got a vulnerability and I find that it's not a false positive, it's active, is it actually at the right level that the company would map it to? So it might have a CVE, CVSS against a critical, but internally, this is an internal-only project. So what I'm going to do is I'm actually going to degrade that from a critical down to a medium. It's something I still want to resolve, but it's not something that will keep me from possibly shifting workloads or having to redo a deployment because I've got that vulnerability. And then I need usually somebody who's more senior who can work directly with security to be able to, when we're remediating, I want to have traceability for remediation. One of the things that I think we're wasting a lot of time on right now is, and we've got this in GitLab today, I'm not trying to sell anybody, is when I remediate an issue inside of one project and that CVE or that security issue is in other projects, we can automatically notify the other teams that have found that CVE what the root cause is and how to remediate that in their own code. Now, where we want to get to is we want to be able to use Gen AI to be able to automatically create an MR that says, hey, I want to let you know, here is the code that actually solves it. would you like to accept this MR, and we'll resolve it automatically for you just by somebody doing a simple code review for inclusion. But that's one of the big things is not just remediating the issue for one project, but how do you then replicate that to every project out? And that's where you get your return on investment for being able to allocate a more senior resource to being able to do that resolution.
And last question is, let's say CVSS score is a 3.5 to 6, that's of course medium, but then in that, like, what's the time frame basically do you manage?
Yeah, so again, you gotta look at from, there's a lot of different companies that I work for. It depends on their culture. If I'm working with Amado at Nasdaq, he's going to sit there and say, that's something that needs to be resolved in the next 2 sprints. If I'm working for some other smaller company, they might sit there and say, hey, put it on the backlog, and maybe we'll hope we can accommodate that in 6 months. So it really depends on the culture of how does that application, Amado and I were actually talking this morning, there's a new feature that we're working on around being able to classify projects. So then what you'll be able to do is, let's say I've got a FedRAMP High project, and then you find a CVSS that's a medium, and FedRAMP requires all mediums to be remediated in X number of days. You can now make that, based off of that classification, you can then build automation around that to enforce that that's happening, and you could even have it where you could block all future merges until that particular issue is resolved. And that's how we're looking at doing a lot of things is providing guardrails and then allowing you to be able to take multiple events and being able to aggregate them together for you to then to be able to build your own custom workflows to be able to define what you want those to look like based on that categorization.
Thank you.
Yep. Great.
Before I introduce our last speaker, everyone sit tight at the end. 3 p.m., Gradle, Inc. and Nasdaq have a surprise. We'll lead you outside, and yeah, something to look forward to. In the beginning, Hans actually kicked off and started sharing about why we need more investment into DPE, developer productivity, and that a lot of times it starts with heroics. I was talking to our next speaker, Brian, who was sharing that all of this that he's about to share with you started as a passion project. So Brian has been at Microsoft for 17 years, and he has what I think is a really cool job of getting to study and measure the well-being of all of the developers at Microsoft. They have quite a few. So with that, introducing Brian to share more with you about it. Thanks, Brian.
One. Wait, where is the actual button here? Perfect, thank you. All right, well, thanks for having me, everyone, and thanks for sticking around for the final presentation. So, as mentioned, I've been at Microsoft a while now. I've done a little bit of everything. I was a traditional developer for a while. I was a traditional product manager for a while. And now my role is a little bit different. The entirety of my job is looking at how we can improve the productivity and well-being of our internal engineers at Microsoft. And while I am very interested in the technical aspects that contribute to productivity and well-being, I'm also looking at some of the additional factors that impact that relationship. So I look at things like our cultural dynamics, our organizational structures, even our physical environment. And in particular, I am interested in how do we define and measure productivity to begin with? And over the last few years, I've spent a lot of time looking at how, just like even the way we work with remote work and hybrid work is impacting that, or even how should we be designing our office buildings, things of that nature. So we'll be diving into what that actually means. So productivity is complicated. You don't need me to tell you that. And like a way that I illustrate that is, if we look back to the beginning of COVID-19, sort of March of 2020, Microsoft shifted to mandatory remote work. We had never been a very remote-friendly company. We were not very used to doing it. And so when we looked at those first couple of months that Microsoft shifted to remote work, we saw some interesting things in the data. We saw that the number of pull requests from our developers went up about 20%. And that's even after controlling for size and complexity of the pull request. So our devs they were producing a lot of code. At the same time, we saw that our stock price had gone up, similarly, 25%. So our devs were doing a lot of work, and that work was resulting in better business outcomes as our customers were buying more Azure subscriptions and Teams licenses. And so you look at this, our devs were doing a lot of work, it was yielding positive business outcomes. Surely we were being more productive, right? Well, no, of course not. If you went and asked any of our developers, they were miserable. They were saying, yeah, I'm working 12, 14 hours a day because I got nothing else to do, but it's not sustainable. This isn't healthy. Or I'm feeling disconnected from my team. I'm feeling really lonely. The days are monotonous. I'm not loving my job. And so if you had looked at just sort of one angle of productivity, or even two angles, you would have said, hey, everything is great. But not until you sort of zoomed out and took a wider lens could you see that, oh, maybe we have a problem here. And so I wanted to dive into this a little bit more. And so I asked 5,000 engineers across the company, well, now that you're working remotely, what are some of the benefits you have seen, and what are some of the challenges that you've been facing? And that relationship was really interesting to me. We saw that they were actually closely related. They were two sides of the same coin, these challenges and benefits. We saw that people said, oh, I'm really enjoying the flexible work hours, but I'm not able to apply it in a healthy way because I'm not happy with my work-life boundary. My days are bleeding out. We saw that individual circumstances varied. Some people said, oh, now I can take more breaks throughout the day. And some people said, no, I have fewer breaks throughout the day based on their individual life circumstances. And we found even for a given individual, their circumstances vary day to day. And so the percentages you see here are the percentage of people who said they experienced a given factor. We see 55% and 49% for those who can't see. And so that adds up to more than 100, which means that some people said they felt that they both had less distractions and had more distractions while working remotely. And so if productivity, if you look at just a couple of lenses and you get different sort of values popping out of it, if our experiences are different day to day and individual to individual, how in the world do we reason over that? Like, how do we actually think about defining productivity, much less measuring it? And so I worked on a couple of papers back in 2020, 2021, looking at this. And the first one is the space framework. And the central theme of the space framework is productivity is not one thing. It is many things. It spans many dimensions. It is how happy and fulfilled your developers are. Are they learning? Are they growing? Because if they're not happy, any gains you see are short term, because you're going to burn out your workforce and you're going to come to a standstill. But it's certainly not just about having happy engineers. It's also about the outcome of what they are producing. Performance in this instance is really about the customer, the business outcomes of what it is you are making. Most people, when they think about developer productivity, I shouldn't say most people, many people talk about activity. How much work did I do? How many lines of code did I write? How many pull requests did I complete? And while that has some sort of interesting insights that we can glean from it, it is certainly not the only thing unto itself, and it is an incomplete measure of productivity at best. But development now, it's a team sport. Are we building off of each other's work? Can other people build off of our work? It's the collaboration. One of the metrics that I am really interested in within Microsoft is when I ask for a code review, how quickly before a human starts it? And so like how much dwell time is there? How much dead time is there? Because that's time that I either have to context switch off to something else, or I have to just wait around. I'm blocked for a human to go and complete some process. And so the way that we communicate and collaborate is incredibly important. We'll talk about that in more detail later. And it's also how efficiently we are able to do this. How much friction do we have in all of our workflows, coming from both our tools and our processes, as well as from humans? And flow state, are we able to sort of do our work free of toil, free of friction? And so I wanted to understand a little bit of what this looks like in the real world. And so I followed it up with another paper where I went and asked developers across Microsoft, in your own words, what is developer productivity? And we find that in practice, developers define productivity very differently. Some people will actually talk about it's, am I satisfied? Am I happy? Am I learning? Am I growing? They will also talk about the business outcomes of the work that they are producing. They will certainly talk about the activity. How much work did I do? In their own words, they'll talk about collaboration. Am I able to leverage the work of others? And they will talk about efficiency. Am I able to do this sort of free of distractions? And so we see that if you ask 100 developers, what is developer productivity, you're going to get 100 different answers. And this is one of the great challenges that I suffer through every day, because executives want a developer productivity measure, and they want to see if that single number is going up or it's going down. But the problem is I don't believe we're ever going to get there without some sort of composite metric that you're going to have to explain anytime you show it to anyone. Developer productivity is many things, and it means different things to different people. And so you really need to look across lots of different dimensions and see how they relate. And so let's see what that looks like a little bit. So as we dig into the data, one of the things that we ask our developers, which I know many other companies ask their developers, is simply, how satisfied are you with the engineering system you use? Which we explicitly define as the tools you are using. And as we look at that, it's really interesting to see this satisfaction measure. Well, what are all the things that impact it? What makes someone satisfied with their engineering system? What even is the engineering system? And there are some obvious things. We found that a developer's satisfaction with their local build environment explains about 20% of their overall satisfaction with their tools. That local build, that interloop build that they're doing dozens of times every day. Well, that's fairly straightforward, right? Well, even that's complicated. And so if you look at two cohorts of developers, which I have done very recently, I looked at two cohorts of developers who are each working in the same repository, the Windows repository. And I saw that one cohort was substantially more satisfied with their local build experience than the other cohort. That dissatisfied cohort, their local builds on average were faster and they failed less often. Well, wait a second. Your builds are faster, they failed less often. Why are you so much less satisfied? Well, the variance in their build speed was more than twice the happy cohort. And so their builds were much less predictable. And so while the typical experience may have been better, they were much more likely to have one really bad experience. And so if you're building and you have 19 great experiences and one crappy experience, you're going to remember that really bad experience, not those 19 experiences. And we can see that in the data. So as we're thinking about measures, even like the basic descriptive statistics we're looking at really matter. Are we looking at mean or average or variance? But we know that it's not just the tools. We see that it's also how we're using the tools. Even just like the code review process can explain about 5% of someone's satisfaction with their engineering system. The number of reviewers, the number of commenters they have on their code review impacts things materially. But it's also how we spend our time. How a developer spends their time explains 10 to maybe even up to 20% of their satisfaction with their tools. And so we're going to talk about this in a lot more depth. But I am particularly passionate about how a developer spends their day. And one of the things that I study a lot is how much time per day is a developer spending actively writing code. We know that developers want to spend their days writing code. They don't want to spend their days reading and writing emails. And so because writing code is a more fulfilling work, or more fulfilling use of time. And so we actually see that the amount of time per day that developers spend coding positively correlates to their overall job satisfaction. It positively correlates to their retention. We've found if you ask 100 developers every day, how productive were you? And then you correlate that to what they actually did that day, the amount of lines of code they wrote or the number of bugs they fixed have no explanatory power over how productive they felt that day. But the amount of time they spent coding did. It was, in fact, the best predictor we found. And so one of the things I talk a lot about internally is what are effective uses of time and how do we recapture more time to spend on more fulfilling work? And so the next slides that I'm going to walk through now are actually, there we go, are actually slides that I share internally when I'm consulting with our internal engineering teams about how they can be more productive. And so the first thing I say is the key is not to stretch your days longer. It's not about working more hours. If I actually go and look at the amount of time that developers spend working after their preferred working hours, it has, of course, a fairly strong and negative relationship to how satisfied they are with their work-life balance, which makes sense, right? Like if I'm working outside the hours I want to work, I'm not going to be happy with my work-life balance. This is a fairly small N here, although each of these teams are pretty large, and it makes sense. And so we found that many developers really struggle with satisfaction with the work-life boundary. I mentioned this earlier. And that has a very meaningful relationship to their self-reported productivity. And so you don't want to burn out your developers, of course. And so if the key is not to stretch the day longer, well, then what is the key? Well, it's finding more time to do focused work, to do that deep thinking, free of interruption. And so we actually measure focus hours, which we define as uninterrupted blocks of time of an hour or more where you're not getting emails, you're not getting IMs, you're not hopping on a Teams call or a Zoom call. And you can see that development teams who have more time for focused work do more focused work, which makes sense, right? Like it's intuitive, but we can go and measure it, and we can look at the things that have a relationship to focused work. And we see that it's not, this comes out in how developers feel as well. It's developers who feel like they have a better ability to focus are much more likely to say that they are feeling productive, twice as likely. I was co-author on a study that actually recently was published where we ran some experiments to see how do we return more time to developers to do focused work. And we had them formally block off time on their calendar. Say like, okay, I'm gonna block myself off an hour. I'm gonna do focused work during this time. And we found that developers who formally blocked time on their calendar did nearly 80% more coding during those formal blocks of time than they do during empty blocks of time on their calendar. And so explicitly setting aside time to code is substantially more effective than trying to find empty blocks of time just throughout your day. And this was true for developers who both chose their own blocks of time and put it on their calendar, as well as developers who had those blocks of time assigned to them by their leadership teams. And so when we look at things like focus days, no meeting days, we can see that that has a causal relationship to increased focus time. And so that is just like one of the most powerful ways to improve productivity in organizations is to set aside the time to do productive work. So, okay, how do we get more focus hours then if we're not going to stretch our days longer? Well, one way is to reduce the amount of time we are in low quality meetings. And so too many meetings is in fact the second most frequently cited workplace challenge for developers. Our days are expanding, particularly during remote and hybrid work, because of all of the 30-minute meetings we have spaced throughout the day. And there are some meetings, collaboration is a part of the definition of productivity according to SPACE. And meetings are an important way to collaborate. And so not all meetings are bad. Well, how do we tell if a meeting is a low quality meeting then? Well, one way is if you're doing something else during that meeting. What I tell teams is if you find yourself sending email or writing code in a meeting, that isn't you being more productive, that's you being in a meeting that you shouldn't have been in to begin with. And so, which is a cultural problem. We see a very negative relationship between the amount of time teams spend coding and the amount of time they spend multitasking in meetings. And yes, I don't think this is directly causal. I think what this shows is a cultural problem. Because yeah, if I'm in a garbage meeting that I don't need to be engaged in, me writing code is better than me just sitting there doing nothing. But I was still in that meeting that I clearly felt some need to be in to begin with. And we see that, yeah, developers who multitask in meetings spend a lot less time coding. And this comes from the top. Managers who multitask in meetings are more than twice as likely to have team members who multitask in meetings. And so regularly looking at your meeting hygienes, like if a meeting doesn't have an agenda, I don't know if I need to be there. And so I may show up because I don't know if there's going to be some decision made that I need to be a part of. Also, recurring meetings, the bane of my existence, because once they're on the calendar, they never go away, they never get re-audited, and so I'll just have recurring meetings that have long since outlived their usefulness. And so regularly going and auditing your calendar and fighting to make sure you are getting just these wastes of time off is incredibly important. But not all meetings are bad. one meeting that is incredibly valuable is just the one-on-ones between a software engineer and their direct manager. It positively correlates to job satisfaction. It actually positively correlates to coding time. An hour spent in a one-on-one is not an hour that you're not coding. It's an hour where you are removing roadblocks, getting prioritization support, feeling part of your team, that connectedness. And it's not just that we see it in the data. Our employees feel it too. At Microsoft, we found that employees who have regular one-on-ones are more than 2.5 times more likely to say that their productivity is going up. They're about twice as likely to say they're satisfied with their work-life balance. And so when I am consulting with our internal teams about how to improve productivity, I don't start with, oh, we'll adopt this tool set or that tool set, although those things certainly matter. It's have your managers prioritize one-on-one, and please, please, please cut out your low-quality meetings wherever you can. So as we pivot a little bit, it is not just how you spend your time, but also just like the very way we work. And we are in a seismic shift in the way that the industry works now with the transition into remote and hybrid work. And so I really wanted to understand, is hybrid work the best of all worlds here? And so there are a lot of advantages of remote work. I recognize that particularly people on this side of the room, you probably can't even read this, but there are lots of benefits of remote work. Just out of curiosity, how many people work full-time remote in this room? Okay, yeah, probably the majority, slight majority. So we see that many employees say that they can focus better during remote work. We certainly see that almost everyone says that they enjoy the fact they don't have to commute anymore. Like that is a huge time saving right there. Even things like the ability to wear more comfortable clothing day to day has a statistically significant impact on someone's self-perceived productivity. Like 99% of the time I am in track pants. But for this illustrious audience, I actually put on jeans today. And so just like, yeah, because I feel more comfortable in track pants, and I feel more productive, certainly. And that is something we are able to see mathematically. It is such a benefit that many employees are willing to accept less money to do it. Of course, this is industry to industry, but it is viewed by employees as such a benefit they are willing to accept lower wages. Not to mention, and there are some competing studies on this, not to mention that it is a helpful way for many companies to achieve some of their sustainability goals, like what is the carbon footprint of remote versus on-site work. But just like there are benefits to remote work, there are benefits to in-person work. Certainly right now, while we're still trying to figure out some of the tools and processes, in-person sort of brainstorming, creative activities do seem to be more effective than remote. If we are able to feed off each other's energy face-to-face, this will, I believe, get better over time, but we are certainly not there yet. And so those creative activities do seem to be better face-to-face. Remote meetings are more fatiguing. Not only do we have more of them, but they are actually more fatiguing. But the cognitive toll on your body is higher. The physiological stress of a remote meeting is greater than doing the exact same meeting face-to-face. Again, we may get better at this over time. It's somewhat referenced by what we're used to, but it's remote meetings, that Zoom fatigue is real that you're feeling. And but even face-to-face interactions are a way of building trust. Teams that spend more time face-to-face are more likely to refer to themselves as we, and so trust building is important face-to-face. Now the great question is, how often do you need to get face-to-face in order to see some of these benefits? The great unanswered question, in fact. And so in theory, hybrid work should be the best because you can trade off the benefits of remote work with the benefits of face-to-face work. And so it's, yes, I can go and do focused work at home, and it's some cadence get together with my peers, whether that is some number of days a week or it's, once a quarter, once a year. We don't actually know. But in theory, hybrid work should be the best of all worlds and should maximize productivity. So are we actually seeing that? Well, I ran a study with some amazing colleagues at Vista Equity Partners, and we surveyed 28 different companies, which includes Microsoft, about hybrid work. And so we wanted to look across a wide range of companies because that showed us different hybrid work policies, different workplace cultures, All of the companies were enterprise software development companies, though. They might have been in slightly different industries, but they're all enterprise software companies, varying sizes. And we wanted to particularly hear from individual software engineers about their experiences and see how much different flexible work policies impacted that. And so first off, we just see that in the real world, there is a wide range of different modes of working. Slightly more than the majority of the developers said that they worked entirely remotely. We also had about 42% said they work hybrid. They are blending remote and on-site work. Very relatively few say they work on-site every day. And so, okay, we see an interesting mix here. And so, okay, hold on. I'm about to flip to my most contentious slide. So one of the things that we did is we asked everyone, how productive do you feel? How happy in your jobs are you? How likely are you, or how often do you look for jobs at other companies? And so I was able to plot someone's self-reported productivity against how often do they come into the office. And this is what we found. And so for those who can't see, down here we have how often do you work in the office on a typical day. 0 days, so fully remote, all the way to I come in the office every day. And as a researcher, I looked at this and said, no way. A perfectly linearly descending line, there's no way this is true. Clearly, this is confounded by something I don't understand, is that maybe people at different parts of their career are more or less likely to come in, and that is influencing this. Or perhaps it's certain companies are more likely to be remote versus non-remote, and that is influencing this. Every single factor we thought to control for, after controlling for it, we saw this general shape. Which I should call out was very, very statistically significant. Remote workers are more likely to feel productive than hybrid workers, who are more likely to feel productive than on-site workers, fully on-site workers. And so, okay, there's a couple of things you could think when you see this for the first time, as I did. One is, well, this is self-reported productivity, and what is that worth? And so one, I'll say, there is no reason that I could think of that remote workers are more incentivized to say, yeah, of course I'm feeling productive, like of course I'm productive, than on-site workers, right? Like we are all equally incentivized to say, oh yeah, I'm super productive. Also, I should note that prior research has shown there is actually a very strong relationship between self-reported productivity from developers and objective outcomes. Developers are actually fairly good at assessing their own productivity. And so what I take away from this is that, and again, I believe hybrid work should, in theory, be optimal, but we're not seeing this. And so what I think this is showing is remote work isn't necessarily less productive. Remote workers can be highly productive, but I think what it really shows is hybrid work is really hard to optimize, and we haven't done it yet. Like hybrid work is tough. How do you get that right cadence? How do you structure your work rhythms around it? And we're clearly not there yet. One thing that was clear is developers want agency. Developers who weren't happy with their ability to choose when and where they work were nearly twice as likely to admit that they were looking for other jobs, and they were also substantially less productive, about 11% less productive. And so, self-reported. And so when I look across the industry and I see many companies having a forced return to office, and you hear sort of the outcry from their developers, yeah, that's what this data would have predicted. This is exactly, I had one CTO tell me that they, as sort of COVID was reaching in more of a steady state, they asked their developers to come back every day, 5 days a week. And that CTO said, when I did that, 35% of my developers quit. 35%. Like, it's not sustained. You can't do that. It's like, so we had to back that off. Like, clearly we can't survive if more than a third of our developers quit. And so agency is important. And so I was interested then, why aren't we seeing hybrid be more effective? Like, why do we see that? At the very least, I would expect it to be equal with remote work in terms of self-reported productivity. Why do we see it as lower? And so I was curious, well, why do people decide to come into the office to begin with? And so for the workers who said they are blending their time between home and office, I also asked, what causes you to decide what to come in for a given day? The number one most frequently cited reason is personal reasons. It has nothing to do with work. It's like, oh, I want to go to the gym, and the gym's near work. However, individuals who made the decision based on the focused tasks they were doing were about 12% more likely to report feeling productive. And so those developers who say, okay, well, I'm going to work in the place that allows me to do my focused work the best, more likely to feel productive. Similarly, those developers who said, oh, well, I'm making a decision based on the meetings I'm having on that day, based on the collaboration, we're about 11% more likely to feel productive. And so not all spaces are created equal. And if I am optimizing to be in the space that is most well-suited for what I'm doing that day, I'm going to have more optimal outcomes. But if I'm making a decision based on personal reasons, it is effectively random if I am in the right spot for the day. And so those individuals who made the decision based on personal reasons, like, about 3% less productive. And you say, 3%, what's that? But like, if I look at a company like Microsoft, I mean, 3%, we're talking about billions of dollars. Like, it's a big deal. And those developers are more likely to want to leave. And so making sure that you are trying to decide based on some work-related reasons does have more positive outcomes. The key, again, though, is not to force people to come back. Individuals who made the decision because they were mandated by their company, they were much more likely, about 9%, to be looking for jobs at other companies. But interestingly, informal team agreements. So when you're working with your team and you're like, hey, if you're going to come in this week anyway, like maybe we should all come in on Tuesday, that did not seem to negatively impact self-reported productivity, and it did not make an individual more likely to say they were looking for another job. And so being able to coordinate with your peers does seem to be valuable. Being told when to come in some arbitrary number of days a week does not actually seem to yield the outcomes that I think many leadership teams would like. And so, where are we going? Come on. So the last slide I have, and then happy to take questions, is I also asked, what have been the biggest work challenges that you have experienced over the last 6 months? And this, to me, was really interesting. So these responses are all scoped to individual software engineers, both remote and hybrid. And the #1 most frequently cited workplace challenge amongst developers, missing social interactions. And so even though many people can come back to the office at some cadence, clearly we aren't finding out the way to do that in the best way yet, because we're still missing social interactions. Now, I should point out that individuals who said missing social interactions was one of their top challenges, they were no more likely to say they were feeling unproductive. They were no more likely to be looking for other jobs. And so this doesn't necessarily fill a business need. This is filling a human need. #2, too many meetings. And so we are feeling that we are spending too much of our day in meetings. In fact, developers at Microsoft can often spend more time in meetings per day than they do actively writing code. And it's just like that, nobody thinks that is the right ratio. And so unlike missing social interactions, which did not seem to negatively impact productivity, difficulty collaborating with colleagues, which 16% of people reported, that did have a substantial impact to someone's likelihood to say they were feeling productive. It also made them about 13% more likely to be looking for other jobs. And so it creates this interesting paradox where I want to interact socially with my team to fill a human need. I need to collaborate with my peers in order to do my job, but I can't do it through more meetings. Too many meetings is not the answer. And so really it's how do we be more intentional with the meetings we already have, as well as how do we get better at things like async communication, which I know at Microsoft, like, we want to be better at, we're not great at yet. And so it is really how do we be more thoughtful and planful with the way we collaborate. Interestingly enough is inefficient work processes, toil, bureaucracy. #3, nearly a quarter of all people said it, it kills productivity. Nobody wants to deal with bureaucratic toil throughout their day. Individuals who mentioned that reported on average being about 9% less productive. They were about 7% less satisfied with their jobs, and were nearly 70% more likely to say they were looking for jobs at other companies. And so when you look at your inefficient work processes, the way that you have to track and manage all of your work items and all of your compliance work, like, the friction you put in a developer's way from that, there is nothing that gets them to want to leave their job more than that. And so like that was, I think, a stat that has stuck with me from this. Just as an interesting thing, as more and more of the dev environments at companies are moving to the cloud, I did see that developers who use a cloud development environment are much less likely to say that insufficient hardware is a top workplace challenge. So if you're looking to figure out what to do with your hardware budgets, moving to the cloud may not always be a cheaper solution, but it does sort of shift where some of that pain is. Something else that I thought was interesting that is worth bringing up is new hires. So, I work in an engineering system team. I expected things like insufficient software tools, which is way down here at the bottom of the list, 7%. I expected that to be a little bit higher. People to say, oh, I want my builds to be faster. You're like, it has a material impact to my likelihood to say I'm satisfied with my engineering tools. So far down the list. But what was interesting is new hires are 40% more likely to say that insufficient software tools was a top workplace challenge. And the impact it had to them was much greater than it had to more seasoned developers. And this is actually a really scary stat to me, because what this says to me is that more seasoned developers just get used to how crappy their tools are. They're like, okay, well, I've written all of the scripts that, I've learned how to use this. I've written all the scripts I need to write in order to get around some of this, and they forget how crappy it is. But new hires haven't forgotten that pain yet, and so this isn't saying that our tools are great. It's saying that oftentimes we have hit our developers over the head with them for so long that they just it got pushed down further into the onion. And so with that, I am happy to take any questions. Oh, we got a few over here.
Hi, I'm curious if you've come across any research or conducted any experiments yourself in how to structure a developer day to maximize focus time. Like, is it better to do your focus time in the morning or the afternoon? Is it better to coordinate with your team or schedule it, whatever works for you, like smaller chunks of multiple 1-hour segments versus 1 2-hour segment? Anything like that?
Great question. And the wildly unsatisfying answer is it depends, because it's so personal, right? It varies individual to individual. But some data that I actually just crunched last week, I saw that individuals who prefer starting their day earlier do have significantly more time available for focused work because there are less meetings oftentimes early in the morning. While it is very individual, the majority of people do feel more productive in the morning. And so when we look at things like having no meeting days, well, that has been proven to help. I actually think a more valuable thing to do is, instead of having one day fully blocked of meetings, you should have no focus hours every day in the morning, but right before lunch. A paper that I just submitted for publication, so hopefully will come out soon, we actually look at activity levels for a developer throughout the day, and we actually see sort of peaks and valleys, and you see now with remote work, a triple peak. And so you see a peak in the morning and then a little lull at lunch and a peak in the afternoon. But I think in general, having time blocked in the morning does seem to be beneficial for the majority of people.
Hi, Brian. So thanks again for teaching us a lot about what makes developers productive and what makes them not productive. I'd love to hear what you prioritize or what you think companies should prioritize in terms of different metrics for prioritization of
Yeah, so if you measure everything, you're really measuring nothing. Now, you can measure, if you focus on everything, you're focusing on nothing. And so I do think, when I'm consulting internally or even when I'm talking to our customers, you really should choose, a few different dimensions of productivity, but choose 3 to 5 metrics to really focus on at any given time, and you can rotate through them. And so things that I actively measure in my job at Microsoft is certainly satisfaction, which I think of as a guardrail metric. I want to make sure I'm not burning out my devs, but I actively measure the amount of focus time devs have available, the amount of uninterrupted blocks of time, because I think that that drives to the right outcomes. And so I think looking at uninterrupted blocks of time, then I think it's really important to measure friction, and friction coming from both automation as well as from humans. And so what is the friction in our PR process? And anywhere I can measure that I am lighting time on fire because developers have to wait around for something to complete is, I want to measure that. So are we making builds faster? Our CI builds, our CI tests, as well as human friction. And so I actively measure the amount of lag time there are in code reviews. And so from the amount of time a dev asks for a code review to when it gets picked up, that's something I measure, and I report on it to very high levels. Because again, it's looking for how can we establish the right cultures. I do care about just time spent coding because it's something that developers want. That makes them feel fulfilled. And so it's also a good indicator of friction, right? If developers want to spend more time coding and they're not, that isn't an indictment on that developer. That's an indictment on the engineering systems around them that aren't letting them do the work that they want to do, which is also a good illustration of why many of these metrics are, I think, wildly inappropriate for sort of assessing individual level productivity. You should never hold a developer accountable for many of these things. You should hold their leader accountable. If a developer isn't getting enough focus time during the day, that's something their leader should be held accountable for. And so there's just a selection of some.
Awesome presentation. Thank you so much for the data. So based on the data that you collected, what are the top 3 companies that stand out to you for spectacular remote cultures? And then similarly, what are the top 3 companies that stand out for spectacular hybrid cultures?
That's a really good question that I am that I'm gonna. I was just gonna say that I'm going to dodge really, really hard. I certainly am not going to cast aspersions on our competitors who may be making decisions for any number of reasons. But I will say, if you find yourself working at a company where your leadership is forcing you back to your office some arbitrary number of days a week, that is probably not the most data-backed decision they have ever made. And again, a lot of it comes from our own personal experiences, right? And it's hard for us to see from other people's perspectives. And executives often, they prefer working in the office. It has been incredibly helpful to them in their careers, and their unique roles are benefited from being in the office. And it's hard for them to imagine, oh yeah, but there are people who are effective working remotely. And it is very, very personal. We actually, even at Microsoft, we see that about half of developers seem to produce more work working remotely, and about half produce more work working on site. And so it varies dramatically individual to individual, which is why having a blanket policy is usually not great. I will say that I love Microsoft's policy, which is, well, by default we support, we encourage sort of hybrid, but we are supportive of remote work, and we certainly do not have, at least at the moment, any mandates.
This is amazing, so thank you so much for all of this. But I had a question around maybe commuting. Do you have any data with maybe distance as well as who's taking it maybe out of their workday versus after or before? So I find that
right. You saw how excited I was for this question. So great question about commuting. So commuting is really interesting because there are some benefits to commuting. We all hate the idea of burning that time, but there's this interesting sort of mental divide, this separation it provides that we've tried to find some digital alternatives for to maybe mixed success is even a good way of putting it. But it's before COVID, people would take the commute out of their workday. And so they said, okay, I'm going to commute to the office, I'm going to work a full day, and then I'm going to commute home. And that commute time was coming out of my personal time. And that's not what we're seeing anymore, which I actually think is a good thing. People are saying, okay, well, if I'm going to go into the office, that commute time, that's coming out of the company time, particularly if they're making me come in. If they're making me come in, I'm going to commute. I'm going to, that's eating my workday. And so if you're commuting in, your workday gets shorter. And so we are seeing people's just mental patterns around commute change, which again, I think is healthy. I don't, for a variety of reasons, look at things well, how close you are to the office. Does that make you more or less likely to come in? They do not give me, for research purposes, everyone's home address, which I think is a good thing. But I would be shocked if commute distance was not a strong contributing factor to your likelihood to come in.
Thank you, Brian. That was really great data. I have a question. You touched a bit the topic of code review and how it can like slow down the process. And did you identify like strategies to maybe help with that?
Yeah.
I know we struggle with that a lot. So.
Yeah. So there's a few things that I recommend to teams. One is just like thinking of it as a cultural attribute and having the manager prioritize code reviews, saying like, hey, people who participate in code reviews, like this is work that I value and recognize. Because code reviews, like, I am a huge fan of code reviews. I'm actually nervous that AI is going to take away some of the need for code reviews. Because code reviews are not just about finding defects. They're this collaborative tool. They're a good way of ramping up new hires. Many developers view code review as a way of just like learning what my peers are working on and like learning new ways of doing things. And so I think code reviews are incredibly important, and having a manager emphasize that from a cultural perspective and valuing participation is just like step number one. But that's not enough, right? It's one thing to say, hey, this is great, do it. But how do you actually do it effectively? One is spread the load. Like wherever possible, don't have one person on your team do all the code reviews because that person just happens to be the one who's enthusiastic about it. And so rotate your code reviews. And like there are teams who automate this. They'll have a round robin queue that's just like, okay, when specific domain expertise isn't needed, we're just going to take whoever's top of the list, and we're going to make sure everyone participates in the code review so that no one gets particularly burned out. When you send your code review matters. And so if we look at when you create your PR, if you do it in the mornings, you're more likely to get your code review taken faster, because again, it's where meeting load is less. If you do it on a Friday afternoon, guess what? You're gonna have to wait a while. And so like when you send out your code review really matters. And so you could even do things like adopt team rhythms and say, hey, we're gonna have focus hours. They're gonna be in the mornings. 45 minutes is for you, complete your work. The last 15 minutes is for code reviews. And so structuring your day a little bit also helps. And I don't know, like, if I'm supposed to stop at some point in time, but I'm going to keep taking questions like until you kick me off.
Maybe last one.
But, all right, last question.
Well, this one will hopefully be fun. So there's a lot of physical infrastructure, like buildings and security and stuff that I feel is probably, why these non-data-driven decisions are made. Well, actually, maybe the data is that this costs money. Right? So we need to use it. Do you have any recommendations for those companies that are feeling that struggle? Like, what do they do, like, to deal with that?
Yeah, so that's a great question. Something I have spent a lot of time over the last couple of years looking at is like, what should Microsoft do with all of our physical space? We, right before COVID, kicked off a horrifically poorly timed, multi-billion-dollar remodel of our central campus. And it's like, well, we've made all of this capital investment. And so absolutely something that people are thinking about is, well, we spend all this money on real estate, we're going to use it, which I think highlights the backwards way that many executives think about productivity, right? Like that is a sunk cost. And like you're spending that whether your people come in or not. And so you really should think about like, how do I maximize efficiency? And you should be thinking about, well, what is our plan for the future and how do we work towards that? And I know this is probably not the answer you're hoping for, but it really is changing the culture around how you think about measuring productivity and showing that like you're fighting against yourself by doing things that are going to be wildly unpopular and maybe not even contributing to what productive outcomes like on a day-to-day basis. And so it's what I tell companies is you should be thinking about how you want to adapt the spaces you have for the uses they are going to have in the future. And so like at Microsoft, one of the things that I tell our design team is like buildings aren't going to be used in the same way. And that's a good thing. You don't need your physical space to be able to do everything. Like it doesn't have to be a space for focused work and for collaboration and for learning and growth anymore the way it used to be. I have spent the last 2 years perfectly optimizing my home office to be perfect for focused work for me. Like, I've had some developers say, when I come back to the office, it feels like I'm going back to the Stone Ages, because like they had so perfectly optimized their home office. That's what I'm looking for. When I go back into the office, I'm going to use that for collaborative brainstorming, creative activities. And so I could imagine a world where, like, in the future, we take some of our office buildings, we gut the bottom half of them and turn them into dedicated, team cohesion rooms where you're brainstorming, you're having team bonding activities where people will come in, teams are coming in every 6 months, and the top half of those buildings are all hotel rooms, right? So we just fly people in for some intense team activities, and then they go back and work in those environments that they have perfectly situated for their productive work. And so I do think we need to think about what the future is, but we shouldn't make misguided decisions in the short term to get there. Okay.
Thank you, Brian.
All right, they're kicking me off stage. Thanks, everyone.
If there are questions that you have burning desire, we want to invite everyone to happy hour at Lantern's Keep. It's at the Iroquois Hotel, which is about a 5-minute walk. So anything that you didn't get to ask, come there. Wanted to close out by just saying thank you all for coming. The DPE Forum, we've gotten such positive feedback. We had one in Seattle, now here. We're going to do a road show. And really it stemmed from my colleague Ruse, who had a brainchild of just wanting to get people in a room to talk about things that they really care about and how to make developers more productive. So if we didn't have Hans, Aubrey, Amado, Lee, and Brian kind of giving us this great content, we wouldn't be here. Thank you to Nasdaq, our partner, for having this, hosting us at this great event, and hopefully we'll see you next year. The recordings will be up in about 2 weeks online, so check it out. Thank you.
fly home in one of our submarines. One
just like birds of a feather. I won't tell no lie. All of the people around us, they say, can they be that close? Just let me state for the record, we're giving love in a family dose. We are family. Hey, I got all my sisters with me. We are family. Get up, everybody, and sing. Sing it to me. We are family. I got all my sisters with me. We are family. Get up, everybody, and sing. Living life is fun, and we've just begun to get our share of this world's delight. High hopes we have for the future and our goals in sight. We know we don't get depressed. Here's what we call our golden rule. Have faith in you and the things you do. You won't go wrong. Oh no, this is our family jewel. We are family. Sing it to me. I got all my sisters with me. Sing it to me. We are family. I can hear you, y'all. Get up, everybody, and sing. Ooh, we have faith in you and the things you do. Hey, hey, I got all my sisters with me. We are family. Get up, y'all. Get up, everybody, and sing. Hey, hey, we are family. I got my sisters with me. I got all my sisters with me. Everybody, hey, hey, we are
Wouldn't it be nice if we were older? Then we wouldn't have to wait so long. And wouldn't it be nice to live together in the kind of world where we belong? No, it's gonna make it that much better when we can say goodnight and stay together. Wouldn't it be nice if we could wake up in the morning when the day is new, and after having spent the day together, hold each other close the whole night through? What happy times together we'd be spending. I wish that every kiss was never ending. Oh, wouldn't it be nice? Maybe if we think and wish and hope and pray it might come true. Run, run, you, baby, then there wouldn't be a single thing we couldn't do. But we could be married, we could be married, and then we'd be happy, and then we'd be happy. Oh, wouldn't it be nice? You know, it seems the more we talk about